I'm going to talk about the focus of our course, Mastering Python for Beginners in Data Science. So let me explain what kind of areas in this particular course we are focusing the most. In fact, because this is a course for beginners, that's a beginner level course, we are not assuming the course taker to have any experience whatsoever about any computer programming language before, not even the problem solving paradigm that lies in computer science. So we will focus on problem solving for a bit, and we will actually start from the very beginning what problem solving is, particularly in computer science. The second focus of this particular course is mainly telling you why we are choosing Python, why Python is so important, particularly for data science problems. The third focus and the main core focus is to learn Python, obviously. Once we know what are the techniques to solve a problem, and once we know that the Python might be a very good language to go with, then what is Python? How to learn it? Well, the Python is the main core and main focus of this course. Obviously, we will start from the very beginning, very beginning, which means we will start from how to install Python. For example, we will start from there. And then we will see what are variables. I mean, very beginning. And then progressively, we will be moving on and on to data structures, to complex structures. But that transition from 0 to onwards, that transition will be very smooth. I mean, whatever you know so far in the course, that will be helping you to gain more complex structures very easily, gaining the understanding of a lot of structures very easily. So in this Python, we will include all concepts of Python in general. And one more thing. After learning this Python, the way we organize this course, after learning this Python, you will be having understanding of other languages as well. I mean, the contents here are explained in so general way, although with the Python syntax, but the concepts are expressed in so general way. The problems that we pick to solve for practice are so generic that you will, after this particular Python course, you will be having understanding of programming languages in general. So data science is one other focus of this course. Actually, the whole course is organized in a way that it teaches you about Python, it teaches you problem solving, it teaches you something about overall programming languages and how computer can be used to achieve the solution of different problems, and using Python, of course. And then we will be introducing the data science packages that are available in Python, because they are really fast, really fundamental, very easy to use, and very powerful to handle large amount of data very quickly for data understanding, for visualization, for cleaning, processing, and a lot of stuff. What we are not focusing at, because that's important, knowing that what kind of things are the things that we're not covering. For example, we are not covering OOP, object-oriented programming. We are not covering exception handling. We're not doing web development or any general kind of tasks that are doable in Python. We are not focusing on those things. Everybody solves different problems every day. Some problems are easy to solve and some are difficult. And yet some are impossible to solve. They are called unsolvable problems. But think about different instances of the same problem one needs to solve again and again. For example, sorting the sale records. And let's say we are sorting the sale records with respect to the sale value, and we have to do it after every 8 hours. If the number of instances, if that number is huge, the optimal choice is to automate the solution, if the automation is possible. But how? How to come up with the automated solution? To come up with a general solution that works for every instance of some problem, that is one thing. But to get that solution running on a computer is yet another thing. Problem solving deals with formalizing a general solution that works for every instance. And programming languages like Python deals with the running of that solution on a computer. Python, as we will see, makes the transition from problem solving to the running solution much easier and quicker. And that's one big plus of Python. A lot of words. I know, a lot of words. Let me take an example to clarify what I said. Hold on till the end of this video, and I will make everything what I said so far crystal clear. So let's take an example. Let's dive into an example to see what I just said. Let's say you are A and your friend is B. And your friend B is always willing to help you. Let's say you found such a friend. And then A just said, I want off just for some days, but B said, but what? Go buddy, enjoy. A said, someone have to do my job in my absence. And then B said, that's it? Is that your problem? I'm available, as always. Go buddy, enjoy. Then A said, great, you're a true friend. Okay, I'm leaving. Wow. And B just said, hey, wait, what do I have to do? What's your job? At the end of the day, I'm going to do your job. What's your job? What do you do? And then A said, after every 8 hours, pick the email of the customer with maximum sales. So that's what you have to do. B said, okay, but from where? I mean, I have to pick that email of the customer from where? Where are the records? A said, oh, there are sales records. I mean, at the job place, there are sales records. And you have to pick the email of the customer with maximum sales. B said, oh, okay. But wait, what should I do with the email that I just picked? Then A said, oh, there is another record called priority records. Just write that email after 8 hours. Just write that email in priority records. And then B said, that's it. That's all your job. And A said, after so relaxed, A said, yes, that's my job. That's all. Now think, A leaves and later that day receives a call from B. And B said, I don't really know what to do. Can you tell me step by step what to do? Focus on again. I'm reading this particular sentence again. Can you tell me step by step what to do? I have sales records with me, having all the records for the last 8 hours. What to do? I just messed everything up. I don't know what to do. And then at the call, A just described a procedure to B for his job. That procedure or a general solution. Let's see the solution. A said, number 1, start from the first record. There may be several columns of the record: the customer name, the customer phone number, the customer email, the customer products that he bought, and the total sales. And the point 1 said, A said, start from the first record and focus just on the sales column. Okay, then after that, go to each next record one by one and find the record with the maximum sales. Obviously, once you have focused on the sales column, you're just comparing sales of different records with each other and will eventually come up with a record that have maximum sales. Number 3, if there are more than one records with maximum sales, it is possible that the maximum sale value, let's say, is 100, whatever the units are, and there may be 2 or 3 or maybe 5 records with the maximum sales, 100. Then which one to pick? A just described here in step 3 that if there are more than one records with maximum sales, then pick the first one from top to bottom and ignore the rest.
I mean, whichever is the, so let's say you have 5 records with maximum sale value. Which record appears first from top to down? Just pick that one and ignore the rest. That might be a policy. That might be a tie-breaking policy, but just do that. And then the 4th step is focus on the email column of the record you found in step 3. In step 3, you found a column with maximum sales. Step 5, see the email address and write that address in the priority records. So that's for the 8 hours. Then repeat this, see the step 6, then repeat this procedure after every 8 hours. I mean, repeat this procedure. I mean, you see the solution A is communicating to B in these kind of steps. It gives a precise idea of what to do. Still, there may be some questions that B is maybe asking. For example, B may ask how to find out a maximum. B might be that person who don't know how to find out the maximum. And third, for example, another question B may ask is that when I'm going to write the email address in the priority records, where should I write? At the very top or at the end or somewhere? But at the end of the day, a solution, a step-by-step solution is required for communication. This kind, if you see the solution, although it has some, it may be explained there may be more steps that should be added, but if you see the solution, this step-by-step solution, this is general solution. This is general solution, much more general solution for every instance. By every instance, I mean after every 8 hours, you'll be having some records and you have to do this procedure on the records for that 8 hours. And then after that 8 hours, you will be having more records to work on. So after every 8 hours, you have the same, the problem is the same, but the instance is different because the records after 8 hours are different. But the solution says whatever the instance you are right now, whatever the instance is that you're in, just perform these steps. A step-by-step solution, coming up with a step-by-step solution, is one module of the problem solving, and this step-by-step solution is called algorithm. Obviously, this step-by-step solution is not always required to be communicated in plain English or in natural language. You may come up with shorthands or shortcuts to explain these step-by-step solution. So the more shortcuts, the more precise and unique meaning keywords you use in your step-by-step solution, the more better communication of your solution takes place. And going from this step-by-step solution, which is just in plain English, going from this to a more concise and unique kind of procedure, that one step that will take us from there to there, that we will see in the next video, will be called a pseudocode. And from that pseudocode, there will be a few steps that will take us to the second major problem that the problem languages will solve, the get the solution running on a computer. So just in this video, I wanted to explain you that solving a problem may not be that hard. I mean, coming up with a solution of a problem may not be that hard, but communicating that solution or writing that solution in a form of procedure that can solve every instance of that problem, that requires a step-by-step treatment of the procedure, and those steps, they should be linked in a sequence and they should be unambiguous. And if a particular step requires more elaboration, that step might be broken down to further steps. But that step-by-step solution at the end of the day is called algorithm. Now, that algorithm might be in English, but we will see in the later video that there are better ways of expressing algorithms better than English or better than natural languages. So, so if you have another problem, come up with a step-by-step solution of that. Every instance of that problem should be solved by that step-by-step solution, which is called algorithm. And in the next video, we will see how to actually eliminate the need of having English with us, and how to incorporate the uniqueness of understanding of these steps or algorithm using the concepts of pseudocode. And after the pseudocodes, we will see it will be very quick to jump to any programming language, and we will see that the Python is very close to what humans generally think. I mean, it's very easy. The transition will be very, very easy. So hope to see you in the next video, and I'll be explaining algorithms in a more kind of keyword way, and in the same video we'll be focusing on pseudocodes, which are basically a pre-step of the actual code in any programming language. So hope to see you in the next video. Okay, in the last video we were talking about the algorithm, what an algorithm is, and how to express that any algorithm. And we saw that algorithm is just a step-by-step procedure, but how to express an algorithm may vary. I mean, you need not always to have plain English or any natural language to express algorithm. The reason is that the natural languages are normally so expressive, and each and every sentence, they may have multiple meaning. So it is a good idea to come up with a structured way to express an algorithm such that each and every statement is completely unambiguous. And one such way is to express algorithms using flowcharts. Flowcharts are graphical ways of expressing algorithms. Here we are taking the problem here we are discussing is computing pay of different employees of some company. And the procedure of, I mean, if there are several employees, let's say employee 1, employee 2, employee 3, and so on. Let's say there are several employees in a company, and having each employee has name, phone number, email, and all the credentials. And then let's say the pay is computed on hourly basis, and each employee has worked certain hours, for example 8 hours, and each employee has an hourly rate, might be, let's say 100 units, whatever the units are. Employee 2 might have worked, for example 7 hours, but the hourly rate of this employee might be 200. Different employees, they might have worked for different number of hours, and each employee can have a different hourly rate depending upon the capacity of the employee or the job nature the employee is doing, and so on. So so if we want to compute pay of all the employees one by one, the procedure of computing pay stays the same. The instances, they differ. For employee 1, the value of hour is 8, the value of rate is 100. For employee 2, the procedure will stay the same. The values of hour and rate, they will differ. So what should be the procedure? The procedure might be that you take the input of, let's say, employee 1, or whatever employee you are going to compute salary for, take the hours value, in a placeholder, call that placeholder as hours, placeholder or a variable. Why this is called a variable? Because for different employees this value will be different. Hours will take value 8 for E1, employee 1. This variable, this placeholder, will take value 7 for employee 2, and so on. Similarly, once whatever employee for which you are going to compute the pay, if you have taken the hours from some records, from some working records, then take the rate for the same employee as well. So input this, that's step 1. Input 2, that is step 2. The sequence of these two steps may change. For example, you take the rate value first and the hours value later than that. But either way, that's one way of expressing this procedure. And then you compute the pay by this formula. So hours multiplied by rate. So maybe this is confusing, writing a star. Maybe we should write this cross symbol because that is more common in mathematics. Or maybe this whole line can be replaced by this particular line, maybe. So pay is equal to multiply hours and rate. Maybe this is more expressive, but it completely depends. I mean, when you start writing pseudocode or whatever pseudocodes you're writing, what kind of keywords, begin is a keyword, end is a keyword, what kind of keywords you're using, and stay with those keywords. For example, if the keyword input is to use to take to get the values to process on, then input should stay everywhere wherever we want to do such kind of operation. If you're using, for example, the value get rather than input, then use get always. But come up with some set of keywords that are expressive as well as concise, and then take the sequence of those statements. Each and every statement should have a unique meaning. It should not be ambiguous. And the sequence should be the sequence describe the flow of what is happening, what is going on. So first we take hours, then we take rate, these two values for any kind of employee, and then we will just multiply them. And after multiplication, whatever decision we want to make based on this pay, we will do that. We may record this value, this pay value at some other records register. We may print that value on a print slip. We may have emailed this value to some other department, whatever decision we want to make. But the procedure really is still here. Then based on pay, whatever action we are going to do, that may differ. Similarly, if we go, this is I mean some kind of structured example of the expressiveness of an algorithm, which is called a pseudocode. And what kind of keywords you're going to use? There are no general keywords. I mean, some people may use get, some people may use a different kind of keywords for it. But it is good to come up with a set of keywords to describe the solution of the problem. In flowchart, for example, every statement here that is here in pseudocode, every statement is described as a shape. Different shapes for different kind of statements. If you want to take input, then you have to describe that action using a parallelogram. If you're going to do some computation, you have to express that using a rectangle. The start symbol and end symbol, the start and end of any procedure in flowcharts, they are described by the ovals. For example, this oval and that oval. Normally the flowchart sequence is from top to down, but it is always good to just print the arrows to describe the flow, because in complicated flowcharts there are loops, there are if conditions, there are so many things. So it is good always to describe the flow using arrows. So now the question is flowchart or pseudocode, because flowchart also looks like very cool way of writing, expressing an algorithm, and pseudocode is also a way of expressing an algorithm. Well, converting flowchart to actual programming code is somewhat tedious. Writing a pseudocode beforehand, which is readable, which is precise, concise, as well as unambiguous, then converting that pseudocode to code of any programming language, that is not that hard, that is simple. And writing flowcharts for very complicated problems is somewhat tedious, because then it also requires another transition from flowchart to the actual programming code. That's why writing pseudocode is more feasible if the goal eventually is to convert that pseudocode to some code of programming language. So you can go with flowchart, you can go with pseudocode, either one is fine, but more feasible way of expressing algorithms is pseudocode. That was just a very simple example. I mean, computing salary of an employee, writing a procedure for that. I mean, this is so simple, nobody may care writing that kind of writing solution of this kind of problem as an algorithm or as a pseudocode or as a flowchart. But the basic idea is the same. Even if you have a complicated problem, even if you have a problem with maybe many more steps, the idea is still the same. In the next video, we will see a procedure how to make tea, for example. That may look to you funny. I mean, do we really want to know the procedure to make tea? Well, the idea is not to learn how to make tea. The idea is to learn how to express the solution of this problem. Making tea, that's a problem. The solution of this, how to express solution of that problem as a pseudocode, and we will see one more example of flowchart as well. So hope to see you in the next video. Okay, in the last video we saw flowcharts and pseudocode. We just took an example of we took a very simple example, computing salary or pay of employee of a company given hours and rate. And I also described whether the comparison between flowchart and pseudocode, and I said that pseudocode is closer to the code of some programming language, which eventually we need, because eventually we need automation of a solution of a problem, and for that we need a code of the code for the solution, the general solution, in some programming language. So flowchart and pseudocode, and then the code of some programming language like Python. It is somehow and sometimes handy to break the problem or to devise the general solution of any problem in first step in a flowchart, because that is more expressive and more generic, more general, maybe in a graphical way. And then once the proof of concept is clear, once it is clear that this is indeed a general solution, it has no bugs inside, it has no errors, it will work always, then we can take another step to convert that flowchart to pseudocode, and then pseudocode can be converted to the code in some programming language. But writing pseudocode right away, I mean from the very beginning without flowcharts, is also a common practice. Either way, whichever way suits you. In this particular video, I'm going to talk about a problem. The problem is making tea. You might be thinking, what are the different instances of this problem? I mean, making tea is making tea. What kind of different instances are there? Well, one person may be liking tea with, for example, 1.5 units of sugar, whatever the units are. And another person may want a tea with, let's say, 2 units of sugar. One person may be needing a tea with, for example, 0.5 units of milk, and another one may be a different units of milk, and so on. So the procedure of making tea should stay same, and the instances, which means the different people want tea in a different kind of combination, that may vary. So let's see a procedure first in flowchart and then in pseudocode for making a tea. For making tea. So let's start. That might look to you a kind of funny kind of problem, but that's a genuine problem. For example, if you want to make tea, what is algorithm for this? So first we start, and then the first step we do is we put tea bag in a cup. That might be a first step. You can argue, should this be a first step? Should that be the second step, and so on? The sequence of, by the way, solving one problem, you can have multiple algorithms for that. And 2 different algorithms may just vary because of the sequence of statements, even if you have the same statements. So I'm not talking about that the algorithm or the general solution is unique. You can have multiple different general solutions or procedures. So for example, putting a tea bag in a cup, that might be first step, or the first step might be to boil the water and pour the water in the cup and then put the tea bag. Both are fine, I mean this way or that way. So let's start with putting a tea bag in a cup. So that's an input. We take a tea bag from somewhere, that's our input. Last time I told you that input is taken as parallelograms. Put a tea bag in a cup and then forget about that cup and boil the water. Somewhere there is a water. I mean, take the water from somewhere and boil it. And see if after, let's say, 5 or 6 or 7 time units, whatever the time units are, see if the water is boiled or not. Assume that there is a test that tells you that the water is boiled or not. So there is a test available to you. So you apply that test and check that the water is boiled or not. If it is not boiled, then keep on boiling. So boil it again. And assume there is a procedure of boiling a water. In normal case, boiling water is just happen by, keeping the temperature high or putting the pot of water on fire or something like so. But that itself is a procedure. So boil the water again and boil the water again. Check if the water is boiled. If no, then boil it again. If boil again, then check. If no, then boil it again. This is called a loop. This is called a loop or repetition. You are doing the same kind of stuff again and again until there is a particular condition that is met. So in this case, the condition is while the water is not boiled, keep on doing the same procedure again and again. This is called repetition or loop. So you boil the water again, check the condition. If the condition is true, for example, the water boiled, yes, then come out. Then you can exit this loop and come out. Then pour the water in the cup. Here we should describe that. Is that the same cup or a different cup? Well, this CUP cup here is acting as a placeholder where this tea bag and the water is going in. So we have a cup, we put tea bag in it, then we put the boiled water in it. But before pouring the boiled water in it, we just boiled the water. Okay, then after we have water in a cup and a tea bag in a cup, what should we do next? We actually first test, want sugar or need more sugar? If yes, then add sugar. So let's apply some arrows. If yes, add sugar, and then again ask, do you need more sugar? Want sugar now? Yes, add sugar. Want sugar? Yes, add sugar. That is again a loop. While you want sugar, you test that the sugar is okay or not. Here you test that the sugar is okay or not, or whatever sugar you need, is that okay or not. Until that condition is not met, you keep on adding the sugar. Add a teaspoon again, then test, add a teaspoon. That is again a loop or repetition. Once the condition is met, want sugar? No. Then exit this loop and ask, want milk? Because some people just take tea without milk. Maybe somebody wants a milk, maybe somebody don't. So want milk? Yes. So add milk. So that's a mistake. This loop should go there, right there, and this line shouldn't be there. That's wrong. Add milk, and then ask, want milk? Yes. Add milk. That's again a loop. Once you exit the loop, then you ask, need to stir? Yes, stir. Then ask again. This line again shouldn't be there. So that's another loop. Once you exit this loop, then the tea is ready. You serve that tea, finish, you are done with the procedure. Now let's see the same procedure in pseudocode. Program is a keyword, and that's what program name is. Program make tea. Put is a keyword. Put tea bag in a cup. While water not boiled. While is a keyword. While this condition is not satisfied, keep on doing this. Whatever written in while and end while is the body of this repetition or called loop. So while water is not boiled, boil water. Then again check, water boiled or not? No, boil again. Keep on boiling. So this is repetition. Once the water is boiled, which means this condition becomes false. Water not boiled becomes false. So water boiled. Then you exit this loop. You pour that water in cup. That's again a keyword. You in a cup, and then you ask, okay, need sugar? Yes, add sugar. Need sugar? Yes, add sugar. So you keep on doing this until you don't need sugar anymore. So that's again a loop. So you might be thinking that why we are writing this add sugar and this boil water to writer to this why we are really indenting this. That's a style of pseudocode to just display that this is inside this particular statement or set of statements are called the body of the loop. And this end while should be here in this alignment. So there is a bug in this slide. This should be here. Okay, once this condition is false, sugar needed? No. Then you can exit this loop and you go here. While milk needed? Yes, add milk. Check again. Milk needed? Yes, add milk. Milk needed? Yes, add milk. Once this condition becomes false, milk needed? No. Then you can exit this loop. You can just go to here. While need to steer, steer T. Need to steer? Yes, steer T. Need to steer? Yes, steer T. Once this condition is false, get out and your T is ready. Do whatever you want to do. This example was so simple, but it expresses a very powerful tool in the pseudocode as well as in flowcharts, and that tool is sometimes called loop, which is there to repeat a particular procedure, whatever procedure you want to repeat again and again until there is a particular condition that is met. That is loop is there. So the purpose of this slide was just to make you convinced and make you comfortable with this pseudocode and flowchart. We will not be talking about flowcharts any further from here on. We will be just talking about pseudocode in just one or two more videos, and then we will be directly going towards we will be comfortable enough with pseudocode for solving certain kind of problems that we will then eventually be moving from pseudocode to actual Python code. And I bet you I'm going to tell you that the pseudocode in the next video I'm going to explain that will be very, very easily will be converted to the actual exact Python code. So in the next video we are going to actually solve a problem of finding out minimum value from a list of values, sometimes called the searching problem. We are going to solve it by first using pseudocode, and then in a later video we will see how to write the actual Python code for that problem. So hope to see you in the next video. Okay, let's dive into a real problem. Let's say you are given a list of numbers. Let's say L is some list with numbers. Let's say we define list by these square brackets. Let's say the list contains 23. Let's say that's a value -4. That's a value 0. That's a value 73. That's a value, and maybe -10. That's a value, maybe 13. That's a value. So let's just take an example that we have 1, 2, 3, 4, 5, 6 values in a list. So and the list is basically we took the list here as L, and we just described that. Let's say the list is declared by or expressed by these square brackets, and the elements of the list, they are separated by comma. That is just our convention for this kind of problem, just for this code. And I'm not talking about any particular programming language yet. This is just a list of numbers. And let's say we want a procedure that finds out the minimum value of any list. Well, first of all, why this problem has multiple instances? Well, we need to come up with a solution that works for any list. For example, if the list has these 6 values, then the procedure should find out the minimum value in this list. The minimum value in this list out of all the values is minus 10, because minus 10 is smaller than every other value. 23 is bigger, minus 4 is smaller than 23, 0 is bigger than minus 4, because the value with negative sign, it is smaller with the value of a positive sign. But if you have two values with negative signs, the value with a bigger number in terms of magnitude is actually smaller in negative sense. So if you compare minus 4 and minus 10 is smaller in minus domain. In positive domain, the result is different. So I was talking about why this problem has multiple instances, why you need a general solution for that. That's a list. Just go and find out the minimum. That is minus 10. Go home happy. Well, we need a solution that works for another list with different numbers, and maybe different number of numbers. Maybe in this list we have 6 numbers. Another list may have 74 numbers. Another list may have 1 trillion numbers. We want to come up with a procedure that always finds out the minimum value in that list. Obviously, the minimum value may repeat. The minimum value may occur more than once in a list. So what is a minimum value? Rather than knowing how many times it occurs, what is a minimum value? That's a problem, finding out a minimum value. And we want to come up with a procedure that finds out the minimum value regardless of the list. Whatever the list is, this procedure should actually return or end up finding out the minimum value. So in this particular case, again, for this particular example, the minimum value is minus 10, and we will take an example of this list and we will see how to code a procedure for that. So, but before starting this procedure, what kind of things we really need to write a pseudocode for this kind of problem? We may start by writing that program, like in the previous video, program name as search, and then we take input list, then we take input the number of values in the list, the total number of values, and then we move on as we want to move on. But writing out a procedure in terms of pseudocode, it is always good to avoid these input statements inside the pseudocode, and always supply whatever needed. Always supply the instance from outside and assume that the instance is supplied, and then just work on that instance rather than reading the instance, rather than taking the values of a particular instance from inside the code. It is always a good practice to supply the instance from outside. So supply the list from somewhere, and this n is really the size of the list. In this particular case, let's say if this is the list, then that list will be there, supplied from somewhere. We will see how to supply that. And this n value here, in this particular case, the n value is 6, the total number of values in the list. 1, 2, 3, 4, 5, and 6. These are 6 values. So it is a good practice to, rather than writing program and then this, just write the name of the problem you are going to solve. In this particular case, the name is search minimum from list. And then this particular, we are talking about this list L with total number of elements as n. Whatever the values inside the L is, we do not know. And this n may take a different value. This L can be different, this n can be different for different instances. But it is not a good practice to take input from inside here. Then one more convention is that, let's say list of 2 represents the second element in the list. In this particular case, L of 2 is basically the second element in the list, which is minus 4. L of, let's say, 3 is the third element in this list, which is 0, and so on. So let's take a convention that whenever we want to access the elements of the lists, whenever we want to read the elements from the list, we will read the element number by giving the element number here. Let's say if we write L of I, that means it means the ith element of the list. So first we take a variable. We are assuming here that the list is supplied to us, the total number of elements in the list is supplied to us. So we first take the minimum value, which we really want to compute, the minimum value we want to compute. But any list can be supplied in this procedure. So what's the procedure? The minimum value that we want to compute, we just consider the very first value of the list. In this case, the very first value is 23. We consider that is the minimum value. Obviously that is wrong. This is not minimum value. Minimum value may be somewhere else, or maybe this one may be somewhere else, but we are not sure that the first value in the list is the minimum value. But let's just hold on for a moment and move on. Let's say the minimum value is this. Here, this is called the assignment. This min value is a placeholder or a variable, and I have assigned this value L1 to it. Now, from here onwards, the min value will be having a value which is 23 in this particular case. Okay, so min value is this, which is 23 now. Let's declare another variable which is called counter. We may need this counter, and let's declare this with 2. Why we are declaring this with 2, it will become clear later on. So now so min value right now for this particular list, the min value takes the value 23, and counter takes the value 2. These are two things for these two variables. Now we apply a loop while counter is smaller than n, smaller or equal to n. Remember, the value of n for this particular example is 6, and counter here is 2. So because counter has value 2, while 2 is less or equal to 6. First check whether this condition is true or false, because if this condition is true, then you will go to the body of the loop. Then this whole box will execute. If this condition becomes false, then you will exit the loop and will go out. So now counter is 2, so 2 is smaller or equal to 6. True, false? That is true. So the condition is true. 2 is indeed smaller than or equal to 6. That is true. So we will go inside to the box and see what happens. Then what we will do, we will pick a value from at the index counter. Right now the counter has value 2. L of counter means pick the value, because the counter has value 2, pick the second value, which is -4, and pick that value -4 from the list. Pick that value and copy that value or assign that value to a variable v. That's a new variable v, maybe needed somewhere. Okay, previously the min value, which is a variable, it was containing the very first value, which is 23. Now we have picked the second value, the counter value is 2, so we have picked the second value from the list, which is -4. Now we compare. If the value now, which is -4, is that value smaller than our minimum value so far? The minimum value so far is 23. So -4 is smaller than 23. Yes, the condition is true. If the condition is true, we will go into this block. Otherwise, we will go into this block. So right now the condition is true. So we will go in this block, and minimum value will just be replaced by the new value. And the new value right now is -4. So because -4 is smaller than 23, so we are here in this body. The if condition becomes true, we are in this body, and the minimum value becomes whatever the value is in v. And right, for this example, the value in v is -4. Okay, so if you go into the if condition, then you're not going into the else part. Either you're going to if part or in the else part, one of them. Okay, so then we move back. Oh, there's a bug here. We need to add the counter. We need to increment the counter here. After this, before this, there is another statement, increment the counter. Increment counter. That's another statement, increment counter. So now increment the counter after this if part, increment the counter, and the counter will become 3. Now we will repeat the procedure and check 3 is smaller than 6. Yes, we will go inside and we will pick, now the counter value is 3. We will go and pick the third entry, and now the third entry will be in V. The V will now contain 0. Previously it contained -4, now it will contain 0. Min value is containing -4 now. So 0 is smaller than -4? No. If 0 is smaller than -4, then do this. But 0 is not smaller than -4. Then go to the else part. And else part is just saying, just go on, do nothing. I mean, don't do anything. So when you're here, don't do anything, exit if condition, increment the counter again. Now you increment the counter value will become 4, and the value at 4 is 73. First of all, check 4 is smaller or equal to 6. Yes, V will contain the value at index 4, which is 73. 73 is smaller than -4. No, do nothing, increment the counter, check the while condition. Now counter will be 5. 5 is smaller or equal to 6. Yes, pick the fifth entry because counter is fifth. The fifth entry is -10. -10 is smaller than -4. Yes, okay. Replace min value with the new value. Now the min value will contain -10. Okay, because if has executed, else will not execute. You exit the if condition and then you increment the counter. The counter will become 6. Now 6 is smaller or equal to 6. Yes, because 6 is equal to 6, hence the condition is true. Now you go and pick the sixth entry, which is 13. Check 13 is smaller than -10 because min value is containing -10 so far. No, that is false. Go to else condition, go to else part, just go on, do nothing, increment the counter. Now the counter will become 7. And you go back and check the condition. 7 is smaller or equal to 6. False. Exit the loop. Okay, exit the loop, go to this condition, go to this statement now. Now you're out of the loop and return the min value. And see, the min value here is containing the actual min value, which is -10. So that's how we search the minimum. This return is also a keyword. So which means if we just use that function, if we just use that pseudocode with if we just use that pseudocode for this different kind of lists with its sizes, whatever the list, this was just one example. If we change the list, the procedure will work. One bug in the code was the increment counter statement was not there. It should be there after this end if and before this end while here. So that was a pseudocode of searching minimum. In the next video, we are going to use this pseudocode, and we will see how to rearrange the values of a list or sort the values of a list such that all the values that are smaller, they become earlier than the bigger values, and the problem is called sorting. So in the next video, we are going to talk about one more problem, very famous problem called the sorting problem. And after that problem, we will be going towards Python, because after that problem, you'll be having a fairly good idea how to solve a problem, how to write a pseudocode for a problem. And the way we are writing the pseudocode is very close to the actual Python code, which will become so clear to you. So hope to see you in the next video. Okay, in the last video, we talked about this, how to find out the minimum value from a list of values. And we came up with an algorithm with name search min from list. Here we have just made a little modification that rather than just returning the minimum value, we are also returning the position of the minimum value in the list. So for example, if the list is 17024, let's say, and 9, let's say that's our list. There are 7 numbers in the list. The minimum value is 0, so the minimum value itself is 0, but that appears in position 3. So when this procedure will end, the min value will contain 0, and the IDX, which is the position at which the minimum value was achieved, that will contain 3. So not only we are finding out the minimum value, but also we are finding out the position of the minimum value. This procedure or pseudocode actually describes a very simple concept. You consider the very first value as a minimum value and the very first position as a position of the minimum value, and then traverse the list element by element and see if you find any value that is smaller than the minimum value so far. If that is found, then replace your minimum value with the new minimum value and update your position number, and then keep on moving till the end of the list. So that's what that's the concept behind this algorithm searching minimum from the list. And to traverse the list, we use this loop, while loop. So next we solve a problem called sorting problem, very famous problem in computer science. So the problem really is, let's say we have a list, let's say 1, 4, 0, 3, 5, and 7, let's say, and the sorted order, the ascending sorted order, is the order in which the list is presented so that the minimum value occurs first, then the second minimum, then the third minimum, and so on. So the sorted order for this particular list will be this. So this is the result. This should be the result of the sorting procedure. So let's see how can we solve this problem. We name this algorithm as sort list, and sort list contains this L. In this particular case, the L is simply this, and this N is the size of the list. In this particular case, the size of the list is 6, so 6. And right now L2 is empty, so although we have to populate L2, but right now it is empty. And counter, again, we initialize the counter with 1, and as long as the counter is smaller than 6, we keep on moving inside this this block. That's the body of the loop. So what we do is we pass the list and the size of the list, and we use the previous algorithm to find out the minimum from the list. So the minimum from the list will be found as 0, and its position will be found as 3. So min value will contain 0 and IDX will contain 3. Then what we do, we pick this minimum value and insert in L2. L2 was initially empty, so we insert in L2, we insert the minimum value, which is 0 so far. And then just in the original list L, we delete the value at the position index. So for example, the index position is 3, so we delete this particular value. So what we really do is we delete this value, we delete this particular value, and the list now becomes with size 1, 2, 3, 4, and 5. So what we do is we decrement the size with 1, and then we move on. Now the counter is 1 again. The n value, rather than 6, now the n value is 5. So 1 is smaller than 5, but the list has no 0 now in it because it was deleted. We search the minimum again, and we insert the minimum in the list. Now the minimum will be 1 in the new list, and we delete that value from the list, and we decrement the size. We keep on moving. Eventually the list L2 will be populated like so, and once this value of n becomes negative, which is -1, we will exit the loop and we will return the sorted list. But see how this sorting procedure actually uses the algorithm that we defined in our previous video. I'm not talking about that this kind of sorting algorithm is the most famous sorting algorithm. There are efficient algorithms, very great kind of algorithms for sorting. But the idea here is not to actually teach sorting. The idea here to actually come up with a pseudocode for this sorting problem, and also to show you how you can use this pseudocode how you can use existing pseudocodes as instructions in other pseudocodes. So that's all about problem solving. If you really understand the selection sort and all that procedure really well, you're actually very good in problem solving, at least the problem solvings that we encounter in the logic that we need to solve different kind of problems in computer science. In the next video, I'm going to actually convert these pseudocodes to Python codes. What do you need to write this sort list procedure in actual Python programming language? And how will you change this search minimum from list in actual Python programming language? We will see the Python details bit by bit in detail, starting from right zero and ending at the very high details of Python. So in the next video, I will just be showing you how to convert this code. But when we will start learning Python, we will start from zero and we will see each and everything of Python in detail. So don't worry, in the next video, if you see things like lengthy codes in a very beginning. These are just because we have arrived at a pseudocode. It is I'm just want to show you how the pseudocodes, which are very expressible, how they can be easily converted to Python programming, just to show you the power of and simplicity of Python programming language. So in the next video, I'll be converting these pseudocodes to Python code, actual programming code. So hope to see you in the next video. Okay, in the previous video, we just get a flavor of problem solving by using this selection sort or the sorting procedure. The idea was just to use this procedure to solve this kind of problem. And we saw in detail, not in that detail, just brushed up, but we saw how to write a pseudocode for solving a problem of sorting, which requires actually a list to be sorting in ascending order, for example. In this video, I'm going to convert first this code, search minimum from list. You see that code, you know that code completely. We're first going to convert that code in Python code, and then we will convert this code in Python code. So see step by step what changes are there. First of all, in Python, that we will see in detail, when you define procedures, different kind of procedures, they are called functions in Python. And rather than writing this, we have to write a def statement before it. And then whatever name we want to write out, the rest of the thing stays the same, except at the very end, we have to write a colon. That's the syntax of Python. So the changes from here to here is a def statement, which defines, that is used for defining, def for define, and then at the end we write a colon. Next thing that we will see in detail. Don't worry if you just see that why we are messing up with lists so early. We will see that things in detail, but just to compare, in pseudocode, normally the lists are the indexes of the list, they start from 1. But in Python programming language, the first index of the list usually starts from 0. So there the minimum value was the first value of the list. Here the first value is actually the index in Python is 0. Rest of the things are same. You declare the variable as in pseudocode, the same goes exactly in Python. Because the index was 1, and so the counter was 1 more than whatever the index was. Here the counter is simply 1. We need to write here idx equals to 0. That we just missed. In the previous, the idx is 1, so here the idx is 0. That's okay. Okay, then next we write while counter is less or equal to n. Same thing, while counter is less or equal to n here. So here we just write the colon at the end. We might have written this equal sign here, this equal sign. We just missed the equal sign. The equal sign is there. So now, but see the difference. Here the while it goes that way. Here we have a colon at the end. Rest of the things are exactly the same. Now v is equal to l counter, v is equal to l counter, the same thing. If v is less than the minimum value, the same thing. If v is less than the minimum value in the pseudocode, Python is exactly the same. Just see the colon at the end. We have colon at the end of the while statement. We have colon at the end of the definition. we have colon at the end of the if statement. The other statement in pseudocode in Python, exactly same. Now, in pseudocode, we have else statement. In Python, we have else statement. If we want to write an else statement, we have to write a colon at the end of that. Then in Python, in pseudocode, we have a pass statement. In Python, we have a pass statement. Same things. In pseudocode, we have end if just to describe that this if ends. In Python, everything is described by the indentation style. So if this indentation goes on, if you're here, then this if goes. If this if goes out. So we need not write ends everywhere. Similarly, the while body has this indentation style. This is all the while body. Whatever that is earlier than this is not in the while body. So rather than writing the tokens end while end if, the Python handles everything using indentation. So no need of end if, no need of end while. Oh, we haven't written a counter here, so we have to write a counter plus here. So counter. So the same statement, we missed this statement in the Python code. So the same statement, exactly the same statement goes here. That's it. The rest of the story is same. We do not need an end search here. The goal here is to show that the pseudocode is, I mean, the way you write the pseudocodes, they are highly they highly resemble with the actual code in Python. Python is that expressive. Python is very high level language. I mean, the way you think the problem in the pseudocode, the actual Python code is much similar to it. So learning the Python is very simple. The simplicity of Python is really a great property of Python, and that's one big reason of popularity of Python. The return statement is same and everything is same. Then we move toward the sorting. Again, we have sort list. We have to write the define, and then we have this colon out there. We have to write the colon there. Then list 2 is defined like empty. It's empty in Python as well. Counter starts from 0 because there the list starts from index 1. In Python, the list starts from 0, so we write 0. While, same as this one. Here we have this colon, maybe an equal sign. Maybe an equal sign should appear here. I guess we are missing an equal sign. But either way, the code is more or less the same. Rest, this statement, exactly same as this statement. We have insert in L2. Here we write append function. I'm in Python. Here we write delete this. In Python, we have a del statement. Rest of the story is exactly same. So you see, converting pseudocode to Python code is way more easier. This is not a formal introduction to Python. I mean, the goal here in this video, in these kind of session of videos, is just to introduce you with problem solving. But I found this. I found this beneficial to show you that the pseudocode actually resembles to the actual Python code a lot. Although we will be dealing with variables, lists, while loops, if conditions, all these kind of stuff in a big and huge detail when we in the upcoming videos, when we will introduce the Python syntax and variables and all that kind of stuff. Actually, you'll be mastering each and everything in Python, and further, you need not write these lengthy codes to do stuff in Python. I mean, the whole that thing is just you write l.sort and you are done. I mean, you need not write a lot of lines of codes in Python. Here I just showed you that if you have a procedure, you can, if you have a pseudocode, it looks like much like the same as Python, which actually tells you the expressive power of Python and simplicity of Python and how it is closer to what you think. But the actual problem solving in Python does not require so many lines of codes. I mean, there are so many functions, so many powerful procedures. For those, you just write one line and a huge amount of work is done for you. And there are very good one-liners for Python. I mean, for programming in Python, You need not to write a lot of lines of code to do some stuff. I mean, a few lines of code, even a single line of code does a lot for you. And for that, you need to know the features of Python, the features and the different kind of syntax and features and libraries and the packages and what is available with Python. I tell you, almost each and everything is available. Just you need to know what is available. Once you know what are the things that are available, you need not to write lengthy codes. You need not to build a lot of logic on yourself. Things are prepared there, waiting for you. You just have to figure them out. What are these things to do? What kind of features are there in Python? If you know that, you are done. So you need not to be writing these kind of codes and lengthy kind of codes. Although knowing that is at a huge advantage, but doing a bigger and bigger stuff, Python will give you a lot of features, a lot of functionality that you need not to go into, and you need not to write a lot of code for it. And that's the second power of Python. One is simplicity. Second, it gives you a lot of features, a lot of functionality, a lot of built-in stuff ready for you. You want to do something, it will be probably there in Python. You need to know where it is. And for that, we have whole future series on Python, to know Python each and every step in Python, and to know important packages in Python. Because knowing important packages and knowing how to code in Python will save a lot of time for you. So spending some time on learning Python will be saving a lot of your time to solve the actual pure problem, whatever problems you're going to solve. And Python is a real programming language, trending programming language. Knowing this language is almost enough. So hope to see you in the next videos, where we will start Python from exactly zero, and we will see each and everything of Python in detail. Hope to see you in the next video. If you're new to data science, you may stuck in choosing the best language for data science. And in this video, I'm going to talk about Python, which is the greatest language so far for data science. To explain the features of Python, let me first go back to a little bit history of Python, from where it started. It basically starts in 1980s. It was introduced first in 1980s, but with constant improvements and a lot of bug fixes, it was officially launched in 1989, 9 years later. It was created by Guido van Rossum, and it is open source, which means it is accessible to everyone. Even though it's open source, it can be used for commercial purpose. The main goal of Python was to keep the code easier to use and understand. Its huge library enables data scientists to work faster with the ready-to-use tools. It is dynamically typed, so the variables that you are defining, they are defined automatically. You need not to set the type. Whatever the contents entering in, the type will be defined automatically. It is more readable and uses lesser code to perform the same task as compared to other programming languages. It is flexible, portable, and can run on any platform easily. It is scalable and can be integrated with other third-party software easily. Python programming is easy to use and has a simple and fast learning curve. New data scientists can easily understand Python with its easy-to-use syntax and better readability. So that's what this point is. Basically, it's really a beginner friendly. If you're new to programming, well, Python offers you very easy environment to go on. It also provides plenty of data processing tools that help in better handling the data. Python is important for data scientists because it provides a vast variety of applications used in data science. It also provides more flexibility in the field of machine learning and deep learning. It has a lot of packages like TensorFlow, Keras, Theano, that is helping data scientists to develop specifically the trending deep learning algorithms very, very quickly. So basically the sport of machine learning and deep learning is huge in Python.
That's huge. As is the case with many other programming languages, it's the available libraries that lead to Python success. Around 72,000 available packages in Python package index, sometimes called PyPy, Python PY, Python package index, PyPy. Around 72,000 packages are available, and they are growing constantly. So huge number of packages, mature packages are available. It is free, open source, and consequently anyone can write a library package to extend its functionality. Data science has become an early beneficiary of these, particularly Pandas, the big daddy of all of them. The other great thing about Python is there are millions of users who are happy to offer advice or suggestions when you get stuck in something. Chances are someone else has been stuck there first. So a lot of community is there, a lot of packages are there, it's open source, it's easy to use, it's easy to learn, it's simple, it's readable, more close to human language, it's high level language. You code less, you do more. I mean, you write a very few lines of codes and you achieve a lot of work. I mean, I've spoken a lot of words here to explain that Python really is best suited language for data science. But let me introduce you some statistics about Python, the popularity of Python with respect to its use and with respect to the job opportunities that are there in Python. So, for example, if you see this chart, in the ranking of top 10 languages, Python stays at the top. So that's the latest statistic collected in 2019, February 2019. And out of the total share of the languages, I mean, around 26% just goes for Python. And the trend is moving up, which means the people are more interested in Python. I mean, the trend of using Python is getting larger and larger as compared to several other languages like Java, JavaScript, C#, PHP, C, R, Objective-C, Swift, and Matlab. I mean, many of them are used for data science, but Python stays at the top. I mean, this is that popular language. And further, if you see, for example, the job opportunities in Python, so that says, I mean, different companies like Facebook, Twitter, and I mean Google and several different companies. This actually graph shows from 2014 onwards that the job opportunities and job postings are in different languages are at what amount. And you can see the graph of Python, although starting a bit low, but then stays up and stays up, which means the if you see the numbers, 85% of the total jobs they're just for Python. And not only, I mean, Python is not just for data science. It's a general purpose programming language. It's open source. It can be used to perform any kind of task, for embedded programming, for posting I mean codes or embedding code on Raspberry Pi, for web development and whatnot. You can do the desktop development on it. You can use the web development on it. You can use the data science. I mean this is general purpose programming language. In other disciplines too, it is performing very well. But for data science, it is almost the default language today. I mean, if you're going to learn data science really, we need Python. I mean, Python really is the choice, the default choice, and we need it. And in this particular course, we are going to introduce Python to you with all aspects. I mean, we will start from the very beginning level, and we will gradually move towards the very advanced programming in Python, including the introduction to the data science packages like
Pandas and Matplotlib for visualizations and NumPy for handling numeric data and stuff like so. So in this particular course, we are really going to teach you Python, and we are not assuming you have any programming experience before. So, and this is one plus of Python. I mean, whether you're an engineer, you're coming from health sciences, you're coming from biology, you're coming from arts, humanities, or from wherever, Python is something that is very easy to get hands on. So if you're not assuming that you have any programming background, you have any data science background, nothing. So we will start from the 0 and we will gradually move to 200. So, and including the introduction to the data science packages. So Python is the best. It is the default. If you're going to work in data science, Python is the default. And we are going to introduce you Python from the very beginning to the very professional. So hope to see you in this course. Okay, before actually discussing the best IDE for Python and particularly for data science, let's first discuss what an IDE is. As you start your coding journey, many of you prefer coding in a text editor, maybe like Notepad++, where you write the code and then open a terminal window to execute your code. When there is an error detected in your code, you switch back to the text editor, correct your errors, typos, and run the code again in the terminal. Everything is fine. Typically for large-scale problems, however, you not only have to code, but you also need to make sure your code works in all scenarios, which means you also need a testing module. Many times you have multiple coding and testing files. And switching between editor and terminal often becomes both confusing and inefficient. So an environment is needed where you can write, you can run and play with your code all at one place. So the one that provides you with the capability of not just coding, not just writing the code, but also testing your code, running your code, highlighting your syntax, bracket matching, auto-completion, debugging your code, code suggestions, and many more features. That is called an IDE, or Integrated Development Environment. Now, there are several IDEs for different languages. For Python, there are several IDEs. For example, Jupyter Notebook is an IDE, PyCharm is an IDE, Spider is an IDE, and Thought Canopy, Vim, Atom, and there are a lot more. There are several of them. Now the question is, for data science in particular, what IDE is the best, or what people suggest to be the best? So before actually showing you the statistics that which one is the best, before actually showing you the actual numbers, the statistical numbers that shows which one is better over the other, let me just go through a few of them, few of IDEs and their features and stuff, and then we will move to statistics and some numbers that will show that which one is better over the other. So let me start with this Jupyter Notebook. For the past couple of years, Jupyter Notebook has been gaining a lot of popularity in terms of coding and debugging. Notebooks have been redefining the concepts of an IDE and are adding more and more features onto it. Jupyter was introduced in 2014 after its predecessor IPython, and from that date, it is really considered to be a bliss in the coding community. Jupyter stands for, some people say Jupyter stands for Julia Python R, but that acronym does not mean just this. Jupyter Notebook today is supporting more than Julia, Python, and R. And by the way, this Julia, Python, R, and R, all these are open source languages and they are best suited for data science. This Jupyter Notebook, it has Markdown editor. It allows you to write HTML code. It allows you to write LaTeX in it. A lot more. Further, this Jupyter Notebook, it's a web application-based server client structure, which is easy to use and allows you create, analyze, and manipulate documents. And all these documents are in the form of notebooks. Since it's a web interface, it can integrate with many of the existing web libraries, for example, for data visualization. Jupyter has so many functionalities. You can write formula using LaTeX, run a Python code and visualization. For example, a raw audio signal using Matplotlib plotting library, all in the same notebook. Jupyter Notebook is not just an IDE, but it's widely used in an educational tool for presentation and even for writing blogs. You can export your notebook from IPython notebook format to PDF or to HTML or even to .py, which is the Python file. The user interface of Jupyter makes it a favorite tool, especially amongst the data science community. And one plus of this Jupyter is it's very quick to start. I mean, very easy and very quick to start. I mean, not much rocket science to write your first code. You want to write your hello world, it's very, very quick in Jupyter to go and do that. PyCharm, if I discuss PyCharm, however, if I discuss some of its properties, let me just discuss first that the PyCharm is by the company JetBeans. And if you have never used JetBeans' other IDEs like Java IDE, then running your first code successfully can eat up a little bit of your time. Actually, a lot amount of your time maybe. Such as, setting an interpreter, PyCharm. PyCharm, however, is much better for working with multiple scripts, handling multiple files and linking them together, and huge large-scale coding projects. The good thing about PyCharm is it supports Anaconda, and as a result, all the packages that fall under Anaconda are supported by PyCharm as well, and those packages including NumPy, SciPy, Matplotlib, and so on. Just like other IDEs, PyCharm has a powerful debugger with a graphical interface. It offers JIT integration. It has secure shell terminal and variant control system. Python IDE is customizable, which allows you to choose between different themes, color schemes, and key binding and whatnot. Additionally, PyCharm lets you add plugins for non-Pythonic files, and these plugins take care of indentation, highlighting the errors, and keywords just on the fly. So PyCharm is also providing, a huge support for coding Python. But the one bad thing about PyCharm, which is not that bad, but one bad thing is it is memory intensive. It eats up a lot of memory. It's a heavy thing. And secondly, getting started with PyCharm is not that quick. It takes a lot of time to just go with that. Spider, however, is a lightweight open source IDE. Oh, by the way, this PyCharm is not. It has professional edition and a community edition, and it is not open source completely. Spider, however, is a lightweight open source IDE that comes pre-installed with Anaconda, and it was built mainly for data science practitioners and engineers. Its look and feel is much like MATLAB. So if you're a MATLAB programmer, if you've used MATLAB before, you switch to Spider and you get, much look and feel the same. Canopy, by the way, the Anthot Canopy also has roughly the same look and feel as MATLAB. But Spider was built for data science community. It is integrated with essential data-centric libraries like NumPy, SciPy, Matplotlib, Pandas, IPython, and whatnot. The built-in capabilities can be extended further by plugins and APIs. Spider contains features like text editor with syntax highlighting, code completion, static code analysis, debugging, variable exploring. It also has profiler that recursively determines the runtime and number of calls for every function and methods called in a file. And there is Anthot Canopy, there is a Vim, there is Atom, there are a whole lot of IDEs just for Python language. But the question really is, being a data scientist, which one should you choose? Being a beginner, which one should you choose? Even for professionals, if you want to stay in data science, which IDE will you prefer over the other? I mean, there are so many of them. I have just described 3 or 4 of them. So let's see some stats based on popularity of different IDEs for data science, and then decide which one is better over the other. So for example, this analysis, the chart I'm showing here, this analysis was done by KD Nuggets, and this is the link for that. And it shows that the most popular Python editors till December 2018. And you can see that the Jupyter is at the top. The second is PyCharm, then Spider, then Visual Studio Code, then Sublime Text, then Atom, Vim, and there are so many others. But Jupyter is at the top. And this is for, these all are listed with respect to the data science community. So in the data science community, which Python IDE is best over the other? And Jupyter is at the top. I mean, it is way out. And one reason to this is its simplicity. It's supporting to so many different formats. It makes an interactive document. It makes a web page that is interactive. You can just change the code, you can make another web page, and so on. You can run it on a local system, you can run it online as server-based system, and whatnot. I mean, it has so much flexibility and very quick start and easy to use. If you, for example, see the popularity of Python IDEs with respect to the employment, then you can see overall the Jupyter is winner as compared to PyCharm, Spider, Visual Studio Code, and Sublime. If you see company or self-employed, still the Jupyter is way out, it is winner. If you see in a student perspective, Jupyter is the choice. If you go to academia or university, Jupyter is the choice. If you are working with government or nonprofit, Jupyter is the choice. I mean, Jupyter is kind of outlier. It is staying at the top everywhere. Further, if you analyze the popularity of Python IDEs with respect to regions, for example, again, overall, Jupyter is a winner. If you see US or Canada, Jupyter is mostly used. Europe, Jupyter is the winner. Asia, Jupyter is the winner. America, Jupyter is the winner. Africa and Middle East, Jupyter. Australia and New Zealand, Jupyter. I mean, these numbers are suggesting that Jupyter is at the top. Not just at the top, it's easy. I mean, and maybe that's one reason why Jupyter stands on the top for the data science. So these numbers and these all statistics suggest that we should use Jupyter Notebook for Python, and we will be doing that. In fact, for this particular course, we'll be working on Jupyter for all kind of coding. And in the next video, I'll be just showing you how to install Jupyter environment, how to install basically Python, and how to run Jupyter for the first time from it. So hope to see you in the next video. Okay, in this video, I will show you how to install Python. There are multiple ways of installing Python. You can go to python.org and install Python from there. I would recommend to use Anaconda distribution. It has Python, it has a lot of packages pre-installed, it has Jupyter Notebook as well. So installing through Anaconda is easier as well. So if, for example, if you're working on a Windows system, you should download the executable for Windows. We will be working with Python 3 rather than Python 2. So you should be downloading Python 3 point, whatever the latest version is. Further, if your system is 64-bit, you should be installing 64-bit version. Otherwise, you will be installing 32-bit version. So let's say you have downloaded the executable file for Windows. Then after the download, you just run that exe file and follow the steps, and you'll be able to install Anaconda. Once the Anaconda is installed, then in the search bar, you just type Anaconda prompt, and the Anaconda prompt
kind of symbol that my mouse is pointing at, this will appear in front of you. You just run it. You will see a command prompt like so. Then in that, just type Jupyter Notebook and press enter, and you'll be having Jupyter running in front of you. Let me show you that on my system how to do that. Let's see. For example, this is my search bar. Let me type Anaconda prompt. So this is the Anaconda prompt. So if I click it, it runs. Then I just type, for example, Jupyter Notebook, and then I just press enter. For the first time, it will take some seconds to run, so let's wait for it. So yes, it runs, and it will show you kind of browser in front of you, and that's what the Jupyter interface is. We will see then how from this Jupyter how to write the code, how to make the code files and stuff, but that's how from Anaconda, after installing Anaconda, that's how you will launch the Jupyter. So this is that easy, no problem. Then for example, you can install Python if you're working on Linux, and just download the version for Linux. And then for example, let's say your file is downloaded in the downloads folder, then run this command bash and this .sh, that's the file name. The installer prompts in order to continue installation process. These kind of commands will appear. Press enter to continue, then press yes, and the installer will finish with the thanks message. After that, you just go to downloads folder and type Jupyter Notebook, and the Jupyter Notebook interface, the browser-based interface, will appear in front of you. You can have, if you're working on Mac, you can download the Anaconda distribution for Mac. Then you'll find an Anaconda navigator, the launchpad. You can launch that, and then just click there's a Jupyter icon in front of you. Just press the launch button, and you'll be having your Jupyter running in front of you. So in this video, we just talked about how to install Python. If you install Python using Anaconda, you'll be having Jupyter Notebook as well. In the next video, we will see how to actually use that Jupyter Notebook interface. For example, I work on Windows, so I'll be having this kind of interface, although the interface looks like the same because it's a browser-based, web-based interface. In the next video, I will show you how to get comfortable with Jupyter, and we will be also writing our first Hello World program in Python. So hope to see you in the next video. Okay, so in this video, I will show you how to write the first program in Python, basically the Hello World program. Before that, in the previous video, I showed you how to launch Jupyter Notebook. So once you launch Jupyter Notebook, whether you are working on Windows, whether you are working on Linux or Mac, whatever, when you will launch the Jupyter Notebook, you will see this web-based interface. And here in the right corner, you can see the button new. You just click it, you will select Python 3, and you will see a beautiful interface in front of you that will allow you to code here. There are a lot of file, edit, view. There are a lot of buttons, kernel, and a lot of controls here. We will see them as we move on, but this is how this is what the coding environment is. This is kind of editor as well as, this is complete IDE interface in front of you. So let's see this interface a little bit step by step, at least the controls that we need. First of all, you are seeing where my cursor is moving. That's the file name or the notebook name. You can change the notebook name, or you can just write, for example, whatever the name of the notebook you want. For example, mastering Python for beginners. Okay, so let's say that's your mastering Python. Let's say 0 to hero maybe. So let's say this is your file name. You just create that file and you see this mastering Python 0 to hero. That file is created. With this file is renamed. Second, this is a cell in which you are going to type your code. The code, I mean, the two modes of writing is, one is you can write the Python code. Another way is you can write the markdown. The markdown is important in a way that if you want to describe your code, if you want to write other stuff other than Python code, you can use these markdown cells and they will be helping you. For example, if I select this markdown and I just select this markdown and I type here, for example, this is Python tutorial, and then I press Shift Enter, it will appear as a heading, and a new cell will be created down. This is also a cell, but this is a markdown cell, as you can see. Now in this cell, that's a code cell. You can switch a cell from code to markdown by just pressing an escape key. When you press an escape key, you will see the color will change here. You can press escape key. Then if you press M, it will change to markdown. And if you press Y, it will change to a code cell. There are several, shortcuts that are available, keyboard shortcuts. If you just see, if you go to help and see this keyboard shortcuts, there are several shortcuts that will be available in front of you. So for example, if you press escape and then press F, you can do the find and replace operation. If you press enter, then that will go into edit mode. If that's important, if you press shift enter, the cell will run and the cursor will go into the new cell. And there are a lot of controls. You should be seeing most of them. I mean, getting a good grip on these controls will help you moving in this Jupyter notebook very quickly. So for example, this is a Python tutorial. That's a markdown cell. You can also create this cell also as a markdown cell, and then you can type here, for example, this is our first program in Python. It is just started here, for example, and it just appears like a description. And again, a new cell is created down, and there you can write your code. So let's write the first Python code, hello world. So first of all, you will write print. Print command will allow you to print anything on the screen. Parentheses, double quotes, starts, ends, and in the double quote you write whatever you want to be printed on the screen. So for example, hello world. And once you have written that code, just press shift and enter, and this code will execute in front of you. So that's hello world printed in front of you. And that's our first program. I mean, writing the very first program in Jupyter Notebook is that easy. Not only that, this Jupyter Notebook will be created. You can just, describe anything. You can write the headings. You can write HTML in it. You can write math using LaTeX. And for example, let me write a LaTeX or math in front of you. Just let's say you are making a notebook that requires some mathematics in it, and it allows you to write mathematics as well. For example, A equals B plus C, shift enter, and that appears like a mathematical equation. Not just this, you can write very complicated equations. And this whole notebook will contain your descriptions in terms of HTMLs or LaTeX or descriptions and code and all that mixed up, whatever. And at the end, you can just download this. You can just download this this notebook as if you want a PDF file. If you want a notebook file, it's a notebook file. If you want a LaTeX, if you want just a Python file, if you want slides, for example, I mean, you can download the same thing as slides. It will make slides for you. So there are a lot of ways of using this notebook, and that's a ready-made document. I mean, you end coding, the document is ready for you. So this notebook is really, really powerful, Jupyter Notebook, and coding in it is not just the coding. I mean, it is preparing a document. If you want to prepare a document, you want to describe anything, you want to add images, and at the end of the day, it will be an HTML document for you. It can be shared on web. I mean, it's ready. Nothing we want to further finish it. So that was our Hello World program in Python. We will continue to build this Mastering Python 0 to Hero notebook. We will continue coding in that. We will describe the headings. We will write the markdown cells and all that stuff. And we will, at the end of this course, you'll be having one notebook with all kind of descriptions and code in it. You can use that notebook afterwards. We will be building one notebook, one complete notebook for Python. So that's about it. That's the Hello World. In the next video, we will see what are the constructs in Python, what are variables and other stuff. But before that, I also wanted to show that this notebook is an enhanced version or the upgraded version of IPython shell. And I also want to show you IPython shell as well. So in the next video, we will just see the IPython shell, and we will see how can we view Python as just as a calculator by using IPython shell. So hope to see you in the next video. Okay, so in this particular video, I'm going to show you the IPython shell. Just open up the Anaconda prompt as before. Like you want to open a Jupyter notebook, then you just type here Jupyter notebook, and you'll be in the notebook world, Jupyter notebook world. But if you just type an IPython and press enter, then a prompt is open for you in a colored way, and this is perfectly fine to write any kind of Python code in here. Actually, the Jupyter notebook is a more enhanced and more featured version of IPython. Basically, everything that is there in IPython is there in Jupyter notebook as well, but it has more features, more documentation and stuff. So for example, if I just write a Python code here, hello world, let's say, it will work in IPython shell as well. But remember, previously in Jupyter notebook, we type shift enter to run a particular command. Here we just press enter and everything will work. If you want to clear the screen here, whatever we typed here, if you want to clear that, just press Control L. If you are on Windows, Control L will work on Windows. Now IPython is just like you can use the Python in this particular shell just like a calculator. For example, you want 2 plus 3, press enter, that's 5. Let's say it's 9 multiplied by 7, the answer is 63. You can write a complicated statement as well. For example, 45 minus 8 is static, or multiplication is achieved by multiplication is achieved by a static symbol 7, and then you can have this minus 10 divided by 2, and just press enter, and that's the answer, 16.0. If, for example, by the way, I have just pressed the up arrow key and the last command just appears. I have pressed up arrow key again and the second last command appears. I press the up arrow key again and the third last command appears, and now I'm pressing the down arrow keys. So for example this, and you may have whatever the result is, you may have that multiplied by 10 and minus or maybe plus plus 15. So the result is minus 145 and so on. So this IPython shell, you can write very complicated or almost, I mean, the complete Python coding can be written in IPython shell, and you can use this shell just for a calculator. Now let's see, for example, you compute this result, let's say 45 minus 9, and let's say you compute this result, whatever the result is, and you save that result in a symbol. Let me call that symbol as a variable. Here the variable is a. Let's say you save that in a, and then you have another variable, let's say b, and 3 static 45 or maybe 3 static 2.6, that is saved in b. Now you have done this particular calculation. You know that 45 minus 9 is in a, the result is in a, and then you have this particular result that is in b, and now you just want to add the two results together, and you want to print the what normal calculators does not have this support of saving the results and reusing them, but here in Python, even if you just want to use the Python just as a calculator, you can declare as many variables as you can, and you can save the previous results, you can retrieve the previous results, and you can use the previous results, save new results, and so on. These kind of symbols that are used to save the results and then they can be just used afterwards, these are called variables, and our next video will be on variables. What are these variables? What are their types? What kind of variables the Python supports? One way or the other, if you want to go beyond calculators, you need certain results to be saved and retrieved afterwards. And the variables are the constructs, the variables are the features that actually do that. So the calculator is fine. You can use this IPython shell just as a calculator, but if you want to do interesting programming, complicated programs, I mean, you want to achieve a task that involves much more calculations, one way or the other, you have to save certain results in somewhere, and then you have to combine the results together, because the longer problems normally are broken up into smaller piece of problems, and each smaller problem has a result that should be saved somewhere, and afterwards the several results, they should be combined to achieve the result that we are after. So these variables are required if you are going to do some interesting or complicated calculations or computations. So you, by the way, before having these Jupyter notebooks, which are just the enhanced version of this IPython shell, the IPython shell, just people used to write a lot of Python programming just in IPython shell, and even today several people are writing their code, complete code in IPython shell. But the Jupyter notebook, it is more enhanced version, more documented, more I mean, it has better interfaces and several features that are better than just using IPython shell. So you have seen this IPython shell, it's very powerful, great, everything is fine with it, but we will be using Jupyter notebooks, which are just the enhanced variants of this IPython for our upcoming coding. So the purpose of this video was just to introduce you with IPython shell, and just to tell you that you can use Python just as a calculator, and even more than that. In the next video, we will be introducing variables in Jupyter notebook, and we will see the Python is really much more powerful than just a calculator. So hope to see you in the next video. Okay, in this video we will talk about variables and operators, the operations that you can perform on variables. A variable, in a very layman term, is basically a symbol that stores some data that can be used later on. So for example, this X is a symbol, character or a symbol, Y is a symbol, X, Y is a symbol. Normally, and these are called names of the variables. For example, this is a variable name X, Y is a variable name Y, X, Y is a variable name itself. Now, these variables, they can store different kind of data. I mean, whenever you want a particular data to be used again and again, it is better to save that data or label that data by a symbol, by a descriptive name, so that you can retrieve that name, retrieve that data by using that label or symbol. So one way or the other, this variable actually is a description of the data that you want to use or store and you want to use later on in your program. Different types of data are there. For example, the integer type data. For example, if the data you want to store is integer type, it's a number, and the number is just the integer number. It does not have a decimal point expansion. That is a type of data, and that can be stored in a variable. In that case, the variable type itself will be integer. You need not to specify the type of variable when you are storing the data to it. Storing data to a variable is sometimes called assigning data to a variable or assignment. For example, if your variable is x and you are assigning a value, let's say 2, then 2 is integer value. It's integer, it does not have a decimal expansion. And when 2 is assigned to x, based on the content 2, that 2 basically is an integer type value, automatically the type of x is set to be integer. And that is sometimes called the dynamically typed. Python is dynamically typed language or dynamic typing. You need not to specify the type of the variable. The contents that you are assigning to a variable, they will define the type of the variable on the fly. And the assignment, for example, in here I am storing 2 inside x, and next time if I want to print, for example, what is there in x, the print value will be 2. Now, this kind of symbol is hard to write. There is no keyboard symbol that looks like so. So rather than writing this symbol for assignment, normally an equal sign symbol is used for assignment. For example, x is equal to 2, that means 2 is assigned in x. Y is equal to 5 means 5 is assigned in y. 7.2 equal xy equals 7.2. xy is completely a new variable. It has nothing to do with x or y. And it is handy sometimes to suggest the name of the variables that are too descriptive, that are very, very descriptive, to increase the readability and management of the code. Because later on you'll be seeing, when you will be working in data science and other stuff, the programs that you will be writing might not be very short programs, they might be lengthy programs. So readability of a program and management of a program becomes an issue if you do not assign the names of the variables carefully. However, if you write the names in a very descriptive way, by just reading the name of the variable, by just reading the variable symbol or the name, it tells a better look and feel of what kind of data inside and what should I do with that. So I was talking about this equal sign. This equal sign is used for assignment. Here, for example, when 7.2 is assigned to a variable xy, automatically the type of xy variable is set to be a floating point number. A float is a data type in Python that describes that the particular data is a real valued. It may have a decimal expansion as well. Not just integer and floats are the only data types in Python. There are several others. For example, you can define complex numbers if you want to. You can, for example, defining a complex number might be, for example, you write the name of C and you write 2 plus 4j. If you write the symbol j here, it automatically becomes complex. And now you can use this C the way the complex numbers should be treated. Similarly, there are other data types like fractions, decimals. There are further data types, the objects called strings. For example, if you assign, let's say, s equals double quotes hello, then that s is also a variable, and the type of this variable is string. String is just a a sequence of a lot of characters, where H is a character, E is a character, L is a character, L is a character, O is a character, W is a character. And when we will define anything, any sequence of characters inside the double quotes and then end the double quotes here, or the single quotes and double quotes, either way, then the type of this S becomes strings, and these characters should be treated as it is. Like for example, if we have another variable S2 and we just say 1, 2 in double quotes, now this S2 is no longer 12 as an integer. It is a sequence of characters where first character is 1 and other character is 2. We will talk about strings in detail in the upcoming videos, but just to give you a look and feel that Python actually supports a lot of data types, a lot of interesting data types, including the most important data type is integer, float, and string as well, that we will see in detail. Further, you can assign more than one values to more than one variables in a single line. That is sometimes called multiple assignment. For example, if you write a comma b equals 4 comma 5.0, then 4 will be assigned to a and 5.0 will be assigned to b. Notice one thing, although 5.0 looks like an integer, but when you write a decimal expansion, it automatically becomes float. So if you now type if you now check the type of A, it will be integer, and if you check the type of B, it will be float. Once you have declared a lot of variables, they stay in the memory, they occupy a particular space inside the memory. For example, X is just a label to a memory. Inside the memory there is 2 located somewhere. Similarly, Y is also located somewhere in memory. And similarly, XY is also located somewhere in memory, and this is the data inside that memory. These will stay in the memory and they occupy the memory. If you decide to no longer use a particular variable in future in the program, then you can call this function del space whatever the variable name, and it will delete the variable from the memory like it was never there. And once the variable is no longer in memory, it is not accessible. If you now access the variable again, you will get an error. Let's see all these concepts. Let's see most of these concepts in Jupyter Notebook, and let's actually define certain variables, use them, print them, do some multiple assignment, and see a lot of stuff in Jupyter Notebook. So let's go to Jupyter Notebook. So that was our notebook that we were actually working on the last time. So let's say I define a variable x. Let's say x is 2. Why not I should describe this as what we are doing here is, let's say, variables. So just to give a heading that we are now in variables. So variables, notice that now I'm in a code cell. Previously I was in a markdown cell. Notice this change. In this particular cell, this is markdown. In this particular cell, this is code cell. See that, code cell. Okay, x is equal to, let's say, 3. Let's enter this. Now x is assigned a value 3. If you want to know how many variables right now are there in the memory, we can write this command whose. This is a percentage symbol. If you write percentage symbol and then just type a command WHOS, it will tell you all the variables that are right now that are there in the memory. And right now the memory has a variable with name x, its type is integer, and the data inside the variable is 3. That's the memory view that you're now seeing. Okay, if you want to explicitly check the type of x, you can print type x. So for example, this function type will actually finds out the type of whatever variable you give inside, and then the print function will help you printing that on the notebook. So if you see the type of x, the type is basically its integer type. Now if you, for example, change the value of x as 3 to, let's say, 5.7. So you have same variable, but you just change the value from 3 to 5.7. So let's see what happens now. So if we call whos again, we have now the variable name is still x, but its type automatically changed to floating point number because we assign a floating point number to it, and this is the data. If we want to explicitly check the type of this x, that would be class float now. Further, let's say we have another variable a, b, c, d, that's a variable name, let's say, and we assign a value 556.32. That's a value. If we now call the whos function, whos command, we will be having two particular values. One variable as abcd, its type is float. Another variable is x, its type is float, and that is there. If we, for example, do a multiple assignment, for example, a comma, when you write comma, first variable finishes, second variable starts. A, B, C, D, F, let's say these are 5 variables. And if you assign 5 values to 5 variables, again in a comma separated list, 3, 5, 6.0, 7.2, and let's say -3. So if you enter that and you now check the status of the memory, because now all these values are assigned to their respective variables. If you now check the memory view, a is an integer type variable with value 3. abcd, the old variable that we assigned earlier, it's already float. B is also integer, it has value 5. C is float. Although 6.0 looks much like integer, but when you write a point explicitly, it becomes a floating point number. So D is again float with 7.2. F is integer, it's -5, and X is the old variable that we know already. Now, if we, for example, delete a particular variable, if we, for example, we no longer want to use ABCD variable, ABCD, that's one variable that we don't want to use in future. And now if we see again the view of the memory, we don't have this. And if we now want to access this, for example, if we want to print this A, B, C, D, we will get an error. And we should get an error because this particular variable does not exist in the memory. It points to no data. It is gone. It is gone like it was never there. So that's about the variables. We just talked about integer and float. There are several other variable types as well. For example, let me just give you an example of a complex number. If you are really interested in, that's a complex number. If you print its type, so that the type is complex. Similarly, you can have a string variable. Let's say hello, how are you? That's a string variable. If you print type of this, you will get a string. We have a whole set of videos just on string data type because this is very important data type. We will see that in detail. But the purpose here is just to tell you that there are a lot of data types that Python supports, and Python is dynamically typed. Whatever content you are assigning to a variable, that content decides the type of the string. You need not to specify. So I end this video here. In the next video, we will be talking about operators, basically what kind of, so once we have decided, once we have declared, once we have defined a lot of variables, what we can do with these variables. Can we add two variables together and get the result stored in another variable? Can we multiply two variables together? Can we have an operation like addition on mixed types? For example, one variable is a floating point number, another variable is integer type. Can we mix up those? Can we add two different types of variables together and get a result, then what will be the type of the result and so on. So a lot of these discussions on operators, the very basic arithmetic operators on these variables, particularly the integer and float variables, we will see that in the next video. So hope to see you in the next video. So in the last video we saw variables, and we particularly saw integer type variable and floating point variable type. We also saw very briefly on Jupyter Notebook, we saw complex and string as well. So in this video we are going to talk about operators, basically the arithmetic operators. Obviously if you are defining variables, you're not defining the variables just to view them later on. Most probably you'll be storing data to the variables, and then you're applying some computation on a set of variables together, computing new results, saving that, and doing some stuff. Most probably you will be adding two variables, one way or the other inside a program. You may have to add two variables, you may have to subtract a variable from the other, you may have to divide a variable, you may have to compute. For example, these are arithmetic operators. Let me just, this plus symbol is used to add two variables. This minus symbol or subtraction is used to subtract a variable value from the other variable value. Obviously these all are operated on values, not the names. Division, like the name suggests, it's if you want to divide this percentage symbol, when it is applied to different variables, if x is on left and y is on right, what it does, it actually divides x by y and checks what the remainder is. For example, if x is 27 and y is 5, then what's the remainder? What do you think? If we divide 27 by 5, what's the remainder? The remainder will be 2. Yes, so the result will be 2 here. So this computes the remainder. This multiplication, this star symbol is used as multiplication. Like in mathematics, we normally write this cross symbol, but in Python and in most of programming languages, star symbol is used to achieve multiplication. This double slash is like the division, but it is division with the result floor to the quotient. What I'm saying is the following. For example, if you divide, let's say 10 by 3, the result will be a floating point number, and the result will be 3.33, something like so. But if you want just a quotient, not the remainder, if you want the integer, that's the quotient value, 10, you write the double slash 3, and it will return just the value that is there before the decimal expansion. So this value will be returned. So this is kind of the integer division or floor division. This double star is used to compute the power. For example, if you want to compute 2, you write double star 4. That means 2 raised to the power 4. In mathematics, we write this as following. And the result will be 16. You can save that result in another variable, or you can just print it, or you can write that in a file or whatever. So these are most important operators. One thing that I want to tell you, that these operators are not just for integers and floating point numbers. The applications of these operators is much broader than these. Later we will see the objects or the data types that are collections and the data types that are beyond these integers and floats, and still there, this plus, minus, division, and all, some of these or all of these, they have their meanings there. Even this plus is used for strings. Now think, for example, if you have a string, let's say hello, and you have another string, for example, let's say this is string s1, and you have another string, let's say s2, which is y, then Python allows you even to add these kind of data types. Although some doesn't make any sense with these kind of string variables, but we will see for different kind of data types, the definition of these operators, they actually change or adapted accordingly. For example, in mathematics, we are much more fluent with plus, with division, with subtraction, and it makes sense to add two integers to subtract a floating point number from another floating point number and stuff. But with data type that is unfamiliar to you right now, these operators may not make that sense to you, but there are definitions, there are ways to use these variables for the data types that are even beyond than integer and floating point numbers. We will see all these details as we move on to the videos, and I mean, as in later on we will see all these things in detail. But just to tell you that these operators are not just limited to integers and floating point numbers or complex numbers. They can be applied to several different data types. So a lot of words. I guess you are bored now. Let's go to Jupyter Notebook and have fun with these kind of concepts that we are dealing with. So yeah, here. So let's first press escape, then M just to change it to markdown, and then escape 1 for heading, big heading, and here I write, let's say, operators, and shift enter, it runs and automatically then go to code. Okay, now let's say I have a variable. So let's say what kind of variables I already have. In the previous video we used that, so we already have these kind of variables with us. Now let me define a new variable. Let's say sum of a b. That's a new variable. Sum underscore ab, that's a variable name. You can have a better variable name, maybe sum of a and b. That might be a variable name. It is good to have the variable names that are descriptive, that describe what data is inside, because in programs, the programs become manageable, readable, and a lot of benefits are there. So sum of a and b, let's say that's a variable name, and you add a, b, you just write a plus b. Let me make the zoom level a little high so that you can see it clearly. So a plus b, let's say that's there. If you press shift enter and now you print sum of, by the way, if you have written sum of, you need not write everything, just press tab and it will automatically complete the remaining part of the variable, and press shift enter and you have 8. If you check the type of this variable, sum of tab automatically completes tab, that is called tab completion. Wow. It's integer. The type of this particular variable is integer. That's a new variable. And why the type is integer? Because a was integer, b was integer, and integer plus an integer is an integer. What if we add an integer with a floating point number? What do you think? What should be the result? If I just type a, that's an integer, plus d with some floating point number. So a plus d, the result will be here, and type of that result, what will be the type of that result? What do you think? Let me pause here for a few minutes, and oh no, not for a few minutes, for a few maybe seconds, maybe 2 or 3 seconds. What will be the result? What will be the type of an integer and a float combined? Well, the types are upcasted, which means the floating point number, the result will be a floating point number, and the reason is every integer by default is a floating point number. A floating point number is an upper class, or you can say a superset. So in Python by default, the types are upcasted to supersets. So here, integer plus a float, the result will be a floating point number, and that's the result. You might be thinking why we haven't stored the result in another variable. Well, if we want to store the result in another variable, we can, or if we just compute the result and apply some operation on that, we can do that. For example, we could do the following. For example, a plus d, that's whatever the result is, raised to the power 3, whatever the result is, divided by maybe 4, and we just save that in a new variable. Let's say let's say the new variable is v. Let's say we save that value in v, and now we print v, and we have the result for v. Wow. So we can do a lot of stuff with these kind of variables. Let me show you fancy stuff that we will see later on. Don't worry if you don't get it. Just S1, for example. S1 is hello, hello, and let's say S2 is world, and we have another variable, let's say S, which is S1 plus S2. What it will do is it will just concatenate them together. We will see strings a lot later on, but just to tell you, this plus is not just for numbers. It is for other data types, very fancy data types that are there. One more thing, let's say we define 10 and we divide it by 3 and we want a quotient. The quotient is 3. However, if we have 10 divided by 3, shift enter, the result actually is 3.33 and so on. You might be wondering, we have not saved that result in a particular variable. So where the result is saved? Actually, if you do not save the result, if you do not assign the result, for example, in this way the result will be assigned to a variable r. But if you do not assign, if you do not store the result in a particular variable explicitly, by default there is a variable in Python which is underscore. Underscore contains the last result that you did not store in a particular variable explicitly. So if that underscore is basically one default variable for the result. If you want, don't try to update this underscore. Just read it. Do not assign anything to underscore. For example, if you assign something to underscore, assignment will be done, but then the properties of underscore will no longer be there as they are in Python built-in properties. Okay, so that's about it, I guess. So that was the operators. We will see the operators more and more later on, but before ending this video, I leave you with a question. So the question is, we saw the variable names like sum of a and b, x, y. Variable name can be lengthy, can be descriptive, can be short, anyways. So the question really is, can a variable name start with a digit? For example, is it possible that the variable name really starts from, for example, a digit? Is a 3x valid variable name? Or for example, at the rate of y, is that a variable name? Or for example, this symbol times 2 times x, is that a variable name? What are the conventions for variable names? Can we write anything? In the left hand side we write, let's say 3x is equal to 4. That means 3x is now a variable name. Is that true in Python? Or are there conventions to define the variable names? So yeah, think about it. I'll see you in the next video with the answer to this. So I hope you'll be having answer for this question. Hope to see you in the next video. Okay, so in the last video I asked you a question about the naming convention of variable names. In particular, I asked you whether 3x is a proper variable name or not in Python. So what's your answer? Yeah, what do you think? How many of you say no? How many of you say yes? Well, by the way, you might have tried that, declaring that variable name in Jupyter Notebook, and then you might have got this answer, one of these. Well, let me tell you, the answer is no. A variable cannot start with a digit, not with at the rate of, not with hash symbol, not with, I mean, there are several other, the special characters are not there except a few characters. One of those is underscore. Let's go to Jupyter Notebook and check this. So for example, 3x equals 5, error, invalid syntax. Let's say at the rate of y equals 4, invalid, star t equals 4, error. Well, an exception is underscore. Underscore e equals 6. That's allowed. Starting a variable name with underscore is allowed. It is different than the underscore that is built in underscore. This is underscore e is different than simply underscore. So it is good to not declare the variable names that start from these because you will be getting errors. Further, variable names should be descriptive. They should give you a look and feel of the data, what they are containing, and you're free to define variable names as descriptive as you want. So it is a good practice to start writing the variable names in a better way. One better notation of defining these variable names, even the function names, we will see the functions later on. One way to defining those is to use camel notation. Camel notation is you start with the variable name with, for example, lowercase letters. Let's say your variable is starting time of the course. Let's say that's your variable name. So you write starting, that's one word, finishes. Then the next word should start from capital T, starting time of the course, let's say. So this kind of notation is called camel notation and very famous, particularly the Java developers. They normally follow this, and several other developers. But you should come up with a notation. That is one notation. There are other ways of keeping the consistent strategy of defining variables. There are several other ways. This is one way. So starting time of the course is, let's say, 2.0, let's say. So that's a variable name. If you now check, that's a variable name. But now if you see this variable, just the name suggests the data inside is doing what. So the names should be descriptive, and make that as a habit. So yeah, I guess we have now answered our question very concretely, that a variable name cannot start with a digit, not with any special character other than underscore. Okay, in the next video, I'll be introducing comparisons with variables. For example, what if you want to compare whether one variable is smaller than the other or not? What if you want to compare whether the two variables, they are containing values, they are same or not? What if you want to do comparisons of the data that is stored inside the variables, and based on the result of the comparison you want to do something else? So in the next video we will see a bool data type that is very, very famous, and it is used a lot in decision making. And we will see the comparison operators, sometimes called the relational operators, in the next video. So hope to see you in the next video. Okay, in this video we are going to talk about a data type which is called bool. That's very, very famous data type. Actually, it's the most famous data type because it is used in decision making. All the control flow, most of the control flow depends on this data type. Although it is very, very famous, very much applicable data type, it is very simple. It is a data type with just two states, with just two values. By the way, there are capacities of different data types. For example, in integer, the different kind of values that you can store are huge. You can store any negative number in it, you can store 0, you can store any positive number. The capacity of floating point number, or the number of values that it can save, is even higher than an integer, and the complex number is even higher than that, and so on. But the bool data type, it has just two states. One state is true. It has just two values. True is a value and false is a value. Just these two states, true or false. in some programming languages, the true is denoted by 1 and the false is denoted by 0. But in Python, the true is just true, true, that thing, and false is false. That's it. If you, for example, define a variable, let's say any variable name, whatever the name is, let's say b, and you assign true, then its default data type will become bool. And if you have another variable, let's say c, which is false, then c is also bool. One thing that is important, there are other operations other than arithmetic operators that we saw, adding, subtraction, division, and stuff. There are other operators that we can apply on bool data type. For example, a true and is a keyword, combining true and true. If there is a variable, let's say a, if there is a Boolean variable a with data true, if there is a Boolean variable b with data true, then a and b is also true. So let's say I've used this variable d in storing this a and b, the d will also be true. So true and true is always true. Further, true and false, this is always false. And this is commutative. For example, true and true is true, true and false is false, false and true is false, false and false is false. So if you apply AND operator and keyword to combine the two Boolean variables together, if both are true, then AND will result a true. Otherwise, AND will result a false. Other than this AND, there is another operator, keyword OR. So this results false if both are false. False, false. False or false is false. If any one of these is true, then the result is true. Remember the difference between and OR. And will result false if any one of the two operands, at least one of the two operands is false, then the result is false. If both are, or and will result true if both of the operands are true, otherwise it is false. Or will result false if both of the operands is false, are false, otherwise it is true. So you now know true, and you now know OR. There is another operator called NOT. This is NOT. So NOT, for example, returns not true results false, and not false returns true. Great. So NOT is a unary operator. Unary means it just takes one variable and operate on that. AND is a binary operator, like plus is a binary operator. It takes two variables to operate on. OR is a binary operator. It takes two operators. It takes two variables to operate on, and so on. So remember these things. One, AND will return true if both of the variables are true. Otherwise, the result is false. OR will result false if both are false. Otherwise, it will return true. And not just flips the state. So not true means false, not false means true. So these are basically, that's how you can combine the Boolean variables together. In the next video, we will be seeing how to apply these comparison operators, and the result will be Boolean types, and how can we combine the Boolean types together to build a better decision making. So in this particular video, I just introduced the Boolean data type with you. In the next video, we will see where the Boolean data type actually appears and how it impacts our programming style or thinking style or coding style. So hope to see you in the next video with comparison operators that actually produces the Boolean variables. Hope to see you in the next video. Okay, in the last video, I discussed Boolean data type, and I discussed that a Boolean variable takes either a true or a false, and we can combine these Boolean variables together with and or operators, and then we can apply a not operator on a particular variable, and we saw that a true and true returns true, and otherwise returns false. Similarly, a false or false is false, otherwise or always returns a true. Before actually discussing these comparison operators, let's just go to Jupyter and just play with a Boolean data type just for a moment. Let us just convert this to markdown cell and just write bool. That's a Boolean variable. So let's say A is true and B is true and C is false, and okay, so these are our variables. Let's press whos to see what are the states of. So A is a Boolean variable with value true, B is a Boolean variable with value true, C is a Boolean variable with value false. So now A is true, B is true, C is false. So let me print A and B. What do you think? What will be the result? Let me print A and C. What will be the result? And let me print C and A. So because A and B both are true, the first result will be true. Because C is false, true and true is true, the other two statements, they will result false. So first value will be true, then false, false. So yes, true, false, false. Let's check the OR. Print, and by the way, let's store that OR in another variable. Let's say A is true or C is false. So what do you think? What will be the result here? Because OR gives false when both are false. Here A is true, so the value of D will be true. Further, not A, because A is true, not A will be false. Similarly, not B, B is true, so not B will be false. Not C, C is true, C is false, so not C will be true. Similarly, not D, we can save the result in another variable, let's say T, and we can just check the type of T if we want. That's a Boolean. We can also check the value inside T, and that is false. Yes, not only that, I mean, we can combine at a higher level. For example, A and B, whatever the result is, or C or D, whatever the result is, and whatever the result is, not of that. I mean, we can combine them in a very complicated way if we want. A and B, the result will be some Boolean. That Boolean and that Boolean, there are. The result eventually will be a Boolean, and then not of that. So let's check what that is. The result is false. Well, why the result is false? Figure it out why the result is false. Let me go to comparison operators. So the comparison operators, let me just go to comparison operators. This equal to, it compares whether two variables, whatever the variables are, whether they are integer, floating point, whatever, whether two variables they have same data or not. For example, x equals to y, that will be true if x and y, they both have same data. So for example, if x has value 4 and y has value 4, then we are just checking x equal to y or not. The result will be Boolean, because, and x may not be a Boolean variable, y may not be a Boolean variable. If we want to compare the values of x and y, then we write double equal without a space inside. Remember, if we write single equal, that will be an assignment operator. If we write double equal, that means we are checking whether the two values are same or not. Similarly, if we write this particular symbol, that checks whether two values are not equal or not. For example, x is not equal to y. The result will be true if x and y, they both have different values. Otherwise, the result will be false. Remember, the result of comparison is always a Boolean. It is either true or false. Okay, next we check whether less than. So for example, if x is less than y, the result will be true if x indeed has a value that is smaller than y. Let's say x is 2 and y is 10. In that case, the result will be a true. Otherwise, the result will be false. Similarly, we can compare the two variables using greater than. We can compare the two variables by less or whether one variable less or equal to the other. For example, if x is less or equal to y, the result will be true of this comparison. The result will be true if x has a value that is not larger than y. As long as x and y, they are equal, or x is smaller than y, in any case, the result will be true, otherwise false. Similarly, greater than or equal to. Okay, so I end this video here. In the next video, we will be moving to Jupyter and playing with these operators and seeing the return types of Booleans, and then combining them together with ands and ors and doing interesting stuff with that. In this particular video, I just talk about the comparison operators, the Boolean data type, and combining them by and, or not. In the next video, we'll be first moving to Jupyter. We will see the comparison operators. We will write all these statements in Jupyter and just get a good hands-on grip on that. And then we'll be moving onwards. So hope to see you in the next video. So in the last video, I talked about comparisons, double equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. So let's go to Jupyter Notebook and see how they actually work. So let me just first enter a markdown cell and type that comparisons. Shift enter, comparisons. So we can compare different values by first assigning them to variables and then comparing those variables, or we can compare the values directly. For example, print 2 is less than 3. What do you think? 2 is less than 3. The result will be what? Remember, the result of a comparison operator is always Boolean. It is either true or false. So in this case, 2 is smaller than 3. So the result will, because this statement is true, so the result will be true and true will be printed. Further, we can store that result in another variable. For example, 2 is smaller than 3. Whatever the result is, the result will be true. The result will be saved in a variable C. If we check the type of C, as long as let's print the value of C. So you can see the type of C is Boolean, and C in this particular case is true. Moreover, for example, let's have 3 equals to 4. Is that true or false? What do you think? 3 equals to 4. 3 double equals to 4. That is false. 3 is not equal to 4. And let's save this result in D. Remember, 3 double equals to 4. That's an operation. The result is false. This equal is an assignment operator that the false value will be assigned to the variable D. And here we can see print D when it is false. Similarly, what do you think? 3 double equal to 3.0. What will be the result? Remember, 3 is integer. 3.0 is a floating point number. And I'm comparing 3 double equals to 3.0. One is integer, another is a floating point number. So what will be the result? Let's see. The result is true because they are comparing the values by discarding the decimal position. Further, let's see. 3 is smaller or equal to, so let's say x is equal to 4, y is equal to 9, and z is equal to, let's say, 8.3, and r is equal to -3, let's say. And these are our variables, let's say. So what do you think? What will be the result here? X is smaller than y. What will be the result of that? X is smaller than y. The result will be true. And z is smaller than y. The result is again true because z is smaller than y. Or r is equal to, for example, x. So what do you think? What will be the result at the end after this? So let's see first this will be true. This will be again true, and that is false. Okay, so this true and true will return true, and true or anything, the result, final result is true. So this will return true. But if I just switch the order, for example, if I just write this statement, which is false, this particular statement here, and then I do this, what will be the result now? Now see, x is smaller than y, it is true. R is equal to x, that is false. So this result will be false eventually. And z is smaller than y, that result is z is smaller than y. Let me just say z is larger than y. Let me just check z is larger than y. Z is larger than y, just to tell you. So this is true, this is false. Both and of these, or let me switch this thing. R equals to x. I just want to show you the precedence of r and x is smaller than y. So now if you see, this is false, this is true, false and true is true, true or false and true is false, this is also false, and the result overall is false. It should happen. But what if this goes first? If this goes first, I mean, I want to show you whether and or, which one of them will operate first. So in this particular case, the result is false, but it can happen. Let me tell you this in more and true or false and true or false and true. What do you think? What will be the result here? True or false and true. If true or false operate first, if true or false operate first, the result will be true. True and true, the result is true. If, however, let me just write a false here. If or operates first, then false or false is false, and false and true is, the result eventually is false. And if and operates first, then false and true is false, false or false. The result in both cases here is false. So a better way of representing these kind of, sometimes they can make confusions. For example, if you have a true here, if you have a false here, for example, false and true, how can I, so false, false and false or true. So in this case, if false or true, that operates first, the result will be true, and false and false, false and true, the result will eventually be false. However, if and operates first, the result will be false here, false or true, the result will be true. So here, if and applies, if and is applied first, then the result, overall result will be true. But if or is applied first, then the overall result will be false. So it is good to know whether and will be applied first or will be applied first. In this particular case, and will be applied first, even if you change this, even if you change this order. For example, even if you pick this thing and you apply here, still the result is and will be applied first and or will be applied after. It is always good, rather than to, one way is to remember the precedence and will be applied first, then or. I mean, it is good to think about the precedence. Another good thing is to specify the order using parentheses. For example, now we specify this first or will be applied and then for and will be applied. So it is good for readability to always apply these parentheses and check the order in which ands and ors and the combinations will be applied. So in any way, the result of these comparisons will be booleans. Question: what will be the result here? So not 2, not equal to 3, and true, or false and true. See this slide for a while. Even if you want to pause the video, see it and answer. The print will return true or false. Okay, with this question, I end this video. In this particular video, we just saw the comparisons on Jupyter Notebook. Just see how the comparisons return true or false. We combine the different trues and different Boolean values using ands and ors. And here is a question for you. Okay, I will see you in the next video with answer of this question. So I left you with a question in the last video. So that was the question, if you remember. So the question really was, what's the result here? So what's your answer? True or false? The result either will be true or false, because these are all comparisons and combination of Boolean values. So let's see step by step. First of all, let's see this 2 is not equal to 3. The result is 2 is not equal to 3. Yes, it is true. 2 is not equal to 3. That's true. So not true. Not true is false. So this is false. So this whole thing is false. Now false and true. False and true, that is false. So this whole thing here till here is false. Now we have or, and then we have false and true. Now false and true is false. So this whole thing is false, this whole thing is false, and or between. So false or false, it is false. So the result of this, so the answer to this question is false. Let me just convince you by typing this statement in Jupyter Notebook. So if you remember, we have print not 2 is not equal to 3, and then we were having, I guess, and false, and yeah, that was a statement or a different one. And true, sorry, that was and true. So this was and true, then we were having or, and then we were having these false and true. So the print ends here, and the result is, oh, I have some parenthesis mismatch. So not true and this, okay, I should have this one, I guess. This goes to there, and this goes to there, and I guess yes. So the result is false. The result is false. The purpose of this question was not just to the purpose of this question is to appreciate actually the fact how we can combine different Boolean values to achieve the final Boolean value. And these kind of combinations will become very, very helpful further in control flow when we will see the if conditions and decision making and stuff. So the answer to this question is false. Yeah. And I end this video here. In the next video, we are going to see some useful functions of Python. And after seeing some kind of useful, there are a lot of functions. We will see just a few of them, very useful of them. And after seeing those functions, then we will directly jump to control flow, basically the if conditions and stuff, where you will see these comparisons, these Boolean values in a much more applicable sense than earlier. So hope to see you in the next video. Okay, so let's have a very quick tour over some useful functions in Python. Obviously there are a lot of functions in Python, but I will be covering just a few of them that I think with the passage of time we will be covering more and more, but let's start. A function or sometimes particularly a built-in function is basically a feature from the language that is supplied for the users to achieve particular task. For example, a round function. If you give round, for example, round, let's say 4.6. This 4.6 is a floating point number, and rounding means make it as integer. What round does is it finds the nearest integer to 4.6, and the nearest integer in this case is 5, because 5 is more closer to 4.6 than 4. However, if you call round, for example, on 4.3, then the result will be 4, because 4 is more closer to 4.3 than 5. So that's one use of round. It rounds basically rounds a floating point number to the nearest integer. Another use of round is if you give another argument, that is called an argument to the function. For example, when you write print, let's say a, this a is called argument to a function print. Similarly, round is a function, 4.6 is an argument. Round is a function, 4.3 is an argument. We will see functions in details, and we will be writing our own functions as well. But for now, just bear with me that functions are these kind of features that are available. However, we will be writing our own functions later on. So this particular function accepts two arguments. So round has two different kind of implementation. One is when it accepts only one input argument, it returns the nearest integer to that. If it accepts a floating point number as well as another argument, like here we have 3, that means after point, after decimal, go to 3 places only and then round up, then round. For example, this 4.55, and then 8 will be rounded based on its next value. If the next value is larger than 5, then 8 will go to 9 and stop. If the next value is smaller than 5, then 8 will stay as 8, and the result will be 3 decimal places after this. Let's practice this round function just on a Jupyter notebook very quickly. Let's see. So here we are. So let's say print round, let's say 4.556, and in this case the result will be 4.5. And the reason is 4.5, when it's rounded up it stays to 5, and the reason is this 4.556, it is more closer to 5 than 4. However, if you just print round 4. Let's say 345, let's say, and the result will be 4, the reason is 4.345 is more closer to 4. However, if you call this round function with more than one argument, for example 4.556789, let's say, or with argument let's say 2, that means the result should be only 2 decimal places after the decimal point. So in this case the result is 4.56, and the reason is this 5 is rounded based on the next digit, and the next digit is larger than 5, hence it is rounded up. So 4.56. If however I call this function for 3, then what do you think? What will be the result? It will be 4.55, and the 6 will be rounded up based on this 7, and it will become 4.557. Yes. However, if for example there will be a value at the place of 7, if there is a value let's say 3, then you call this function then 4.556, and then based on the next value 3, the 6 will stay as 6 rather than going to 9, and the result will be 4.556. Yeah, so that's the round function basically. Another function is div mode. Div mode function basically divides and returns quotient and remainder. So in the next video we will be seeing this div mode in detail, how it actually works and how it is useful. So in this particular video we saw round function. In the next video we will see div mode, and there are a couple of more functions that we will see in the upcoming videos. So hope to see you in the next video. So in the last video we saw round function that sometimes accepts 1 argument and sometimes accept 2 arguments and behave accordingly. In this particular video we are going to see another function, div mode, and it accepts 2 arguments, 2 different arguments, maybe same or different arguments, and it returns 2 outputs, 2 numbers. It returns basically quotient and remainder. For example, in this particular case the quotient is 5 and the remainder is 2, because if 27 is divided by 5, the result is 5, but then the remainder is 2, and the result is returned in a kind of an ordered pair, and these kind of collection in which we have 2 or more elements, we call these collection as tuple, that we will see in detail when we will see the data structures module of this course. But right now just bear with me that it returns 2 numbers, 2 elements, and the 2 elements are ordered in an ordered pair, which is called a tuple. A tuple is not just an ordered pair, it can have 3, 4, 5 or 7 or maybe several elements, but right now we will a tuple is just an ordered list, which we will see in detail. So let's see the working of this div mode function in Jupyter Notebook. Let's see. So let's say we have div mode. Let's say for example we have 34, and then we have let's say 10, or maybe let's say 9. So what do you think? What will be the quotient and what will be the remainder? So 9, 18, 27. So 3 is the quotient, and the remainder is 7. So 3 is quotient and 7 is the remainder. So and if you save the result, for example, if you save the result in a variable, let's say g, so if you see the g, the type of g, if you just type the type of, if you just print the type of g, it's a tuple, which we will see in details. And if you see the contents of g, if you see the contents of g, the contents of g are 3 and 7, and if you want to access each element independently, then you can access the first element, because if there are multiple elements in a variable, normally that kind of variables are called collections that we will see in detail later on. And these are the indexing, the positioning is start by 0 rather than 1. So G0 means the first element of G, which is 3 in this case, and the second element of G is 1 at 1, which is 7. So this is basically, this is called the index or position of elements or data in this particular collection. We will see these indexing and all these kind of collections in detail in the data structures course, when we will see arrays and strings and different kind of structures. But and div mode sometimes is basically sometimes it is helpful. By the way, you can achieve div mode by another thing. For example, if you want to achieve div mode 34:9, you can do the same thing by, let's say, 34 divided by double divided by 9. That will give you a quotient, and the quotient is 3. And further, if you write 34 remainder 9, and that will give you the remainder that you need. So you can call that function div mode, or you can use these two. There are multiple ways of doing the same stuff. Okay, so yes, so I mean, sometimes it is useful when you're coding and knowing this kind of function that returns quotient and remainder. Okay, next function that is more useful is instance, and we will see this function in the next video. So hope to see you in the next video. Okay, this function is instance. It actually returns either true or false, and it just checks that particular given data value belongs to this type or not. For example, if you want to check whether 1 has type integer, so you can check that using this function. By the way, you know that 1 is of type integer, then you may think that why on earth one should be interested in checking the type of 1 if somebody know it is integer. Sometimes we have certain variables and certain data is stored in it, and we want to check the data inside it belongs to which kind of type. And in several cases, the value to this variable is not assigned by us. It may be read from some file, or maybe through input a user gives some number or something like so. So sometimes it becomes important to check the type of a particular variable. If we are expecting a particular type of the input and the input is different, then this function might be helpful somewhere. Either way, this is a function available in Python, and it checks whether the given value has a particular type or not. So is instance 1 int returns true, is instance 1.0 integer, that returns false, maybe because this is a floating point number. And you can check a particular value belongs to one of the several types or not. You can give several types in a tuple, and you can check whether it belongs to this this or not. So let's go to Jupyter Notebook and see actually how it works. So by the way, this is the same notebook that we have that we are populating. So hold on with me. At the end of the day, we'll be having one notebook complete. So is instance, let's say 3, is that instance of integer? The result is true in this particular case. If, for example, we check whether is instance 3.4, is that an integer? The answer is no, it is not an integer. If, for example, we check if this is not an integer, then maybe it is a float. The answer is yes. Or maybe we check that, for example, if that value is either float or integer. If it is one of these, then check that a particular value, in this particular case 3.4, whether it belongs to one of these types. We can increase these types, for example. So let's say we gave a complex number here and check is instance, let's say 2 plus 3j, that's a complex number, and let's say we ask whether it is an integer or float or not. The result is obviously false, and the reason is it is neither integer nor float. Or even if we give a string there, str, so it will still say no, it is not any of these. But maybe there is a complex data type. If we see that says yes, because it is complex. So sometimes this is instance becomes really useful. Next function is power. So power, you can compute power, by the way, using for example, if you want to compute x raised to the power y, you can use double star, and that computes exactly x raised to the power y. Or equivalently, you can call the function pow x comma y, and that will give you the same result as this one. But power sometimes take 3 arguments as well, and in that case it performs the power function in a different behavior. So for example, if you supply 3 arguments, what it does, it raises y to x raised to the power y, whatever the result is, then it takes the remainder by z and gives the result. So let's see the functioning of this power function in Jupyter Notebook. So let's say power, I want to compute 2 raised to the power 4. The result is 16. No problem. 2 raised to the power 4, I can compute the result 16 this way as well. But here is another way. How can we use this? 2 raised to the power 4, whatever the result is, then I want to take the remainder by, let's say, I want to take the remainder by 7. 2 raised to the power 4 is 16, then if we take the remainder by 7, the result will be 2, and that's the result 2. So that's how you can use this power function. I'm just introducing you some built-in functions that are available. There are so many functions that are available. I'm just getting you comfortable with these kind of functions so that in future, if you see another function that you have not seen here, you'll be able to use it and apply it. In this particular video, we saw this is instance function and this power function. In the next video, we will see one more function that will allow you to take input from the user. So far, we are supplying values or assigning values to variables directly. What if on the fly we want to give the values, and those values should be assigned to the variables? So in the next video, we will see the function. We will see a function that will allow you to give input from the keyboard. Hope to see you in the next video. So in this video, we are going to see a very important function called input. This function is this is beneficial for taking input from the keyboard from the user. The way to call this function is you type input, and then you type a message that actually describes the expected entry. That, for example, enter something. If you want somebody to, or tell somebody to just enter, let's say, a number, you can write enter number, or any specification to help the user to enter whatever input the user want to enters properly. One thing is that no matter what the user will enter, the variable a will be having type string, str. So even if you enter a number, let's say 12 or 34 or whatever, that will be received as a string. And then there are ways to convert string to number if that really was a number. So whatever you receive using input function will be a string, and then there are ways to deal with that string if that was a number, how to convert that string to a number, and so on. So for example, let's see on the Jupyter Notebook how it works. So let's see, for example, x is equal to input, enter a number, let's say, and then if I press shift enter, a prompt will appear in front of you that will require you to enter a number. For example, if I enter, let's say, 56, and then I press enter, not shift enter, enter, then x will receive 56. Now you might be thinking this 56 is an integer, so the type of x should be an integer, but this is not the case. The type of x will be a string. And the reason is whatever you enter is received as characters 5 and 6. Even if you have entered something else, that would have been received as a sequence of characters. So this is no longer a 5 as a digit 5, 6 as a digit 6. These are some characters, sequence of characters. Now, if you want to, I mean, there are ways to convert this X. For example, maybe you want, let's say, Y or X as int X. So this means you have now converted this string to integer, and then whatever the result is, you have stored that result in X again. If you now see the type of X, the result is integer, and you can, for example, print X minus 34, and the result is 22 because X was 56. So this input function is, I mean, it is, and one way, by the way, if you're expecting an integer or a float value, for example, let's say you are expecting a float value, then it is good to write input, let's say, enter a real number, maybe, or any message, and then at this particular time, at the time of input, then it is okay to convert that thing to a float, and it will become a float. Yeah, that's it. So now, for example, you enter 12.5. If you see the type of A now, type of A will be float. Okay, but there are problems. For example, if you're expecting float and somebody enters something that is not float, for example, A or let's say B equals float input, enter a real number, let's say, and then you press shift enter and somebody just enters, let's say, ABC. So now this is not a float. ABC cannot be converted to a real number no matter what, so you will catch an error. There are ways to avoid these kind of errors and program breaks using exception handling, and there are other ways, but be careful. I mean, the user is not, I mean, the one who is going to enter the input, if that user is not restricted enough, then you can get errors. I mean, this is not the case that whatever you will enter, it will be converted to a float. If whatever you have entered is really convertible to a float, then it can be convertible to a float, not otherwise. And at the input time, there is no restriction. You cannot restrict the keyboard to enter what or what not, although there are ways to do that. So that's about the input function. So we have seen some of the functions. Let me just go through quickly. We have seen input, we have seen is instance, we have seen div mode, we have seen power function, we have seen the round function, and there are several others. Yes, so from now on we will be actually moving towards basically decision making based. Sometimes we will use these kind of functions. Mostly we will be using input function, but sometimes we'll be using maybe other functions like these functions, and sometimes we will be doing decision making based on these and stuff like so. One thing that I want to tell you is, if for example you know the function name, some function, let's say like power, you know that POW, power, is a function, but you do not know how to use that function. One way is to just type a question mark in front of it and then just press shift enter, and in front of you the documentation of the power will open up. So it will tell that this is power, that's how it should be called, and then some description will be in front of you, that equivalent to x raised to the power y with no arguments, with 2 arguments, or equivalent to x raised to the power y remainder with z with 3 arguments, and so on. If you want to see implementation of this function as well, we will see the functions later on, but if you want to see more about the help, you can type the double double question mark, and more things should be open up in front of you. So yeah, in this particular case, the This power function does not have an implementation in Python, so the single question mark and double question mark are the same. One more way is to use the help function, help pow, and you will get a lot of information about the power, how for example help on built-in function pow in module built-in, so this is pow, this is equivalent to this, some key types and stuff like so. Or for example, you want to know how can I use the input function, for example, so you can write help on input, and this is how this can be used. So sometimes it is okay if you know the name of some function and you know how to use it, you can just open up the documentation right here in Jupyter Notebook by either using a help function, or you can use just a question mark in front of the name and so on. So that's about the functions. In the next video, we will be seeing the power of comparisons and the decision making, or sometimes called the control flow. So the real fun will begin from the next video, because we will be actually deciding which part of the code should run and which part should not run based on certain conditions. So hope to see you in the next video. Okay, we are in control flow, the most interesting part of any programming language. Well, assume that you have two numbers. You have taken two numbers from the user, A. You have taken that number from the user using input. I have not supplied the input message here. The message is optional. It's a description. If you supply that, that's okay. If you don't supply even that, that's okay. So A is some number the user will supply when the code will run. B is some number the user will supply when the code will run. Now, once you have A and B in front of you, obviously the user will supply that on the fly. You don't know what the value of A and B are, because when the program will run, only at that time the A will be populated and B will be populated. Your task is whatever the value of A is that you don't know, whatever the value of B is that you don't know, the user will supply those values. Your task is to print the value that is bigger than both. So for example, if A is bigger than B, then print A. If B is bigger than A, then print B. So whatever the bigger value is, print that value. Let's say that's your task. How can you do that? So the question is how? Does Python allow us to do that? For example, if A is bigger, then we should print A. If B is bigger, then we should print B. Remember, again and again, we are talking in terms of if A is bigger. If so, this is what, if A is larger than B, then this condition will be true. This is like the comparison. So this is true. But then we must have an if condition as well. If A is bigger, then do what? So if A is bigger than B, then do certain things. Otherwise, don't do those kind of things. So this if condition is really, really powerful and is available in all programming languages. In here, for example, let's see if A is an input, B is an input. Writing an if condition, that's if is a keyword. That's a comparison that we have done earlier as well. And then the syntax required a colon in front of that. So if this condition is true, if this comparison results true, remember the comparisons, they return Boolean values. If this comparison, if this, whatever the result of this operation is, if that is true, then you go into this block. And whatever the statement inside is, do that. For example, print B is greater than A. Now my question is that done? Are we done with the task? The task was to print the bigger number. If B is greater than A, then B will be printed. Then, or we might have printed, for example, we might have printed, rather than writing this, we might have printed, let's say, just print B, because B is bigger. If B is not bigger than A, what we will do then? So yeah, if B is bigger than A, then B will be printed. Yes, because then you will be inside here. if b is not bigger than a, if this condition is false, we will do what then? So that's a question. So right now I'm just coding this in Jupyter Notebook, and then we will see how can we deal with that if b is not bigger than a kind of condition. So let's first see the blessings of if condition in Jupyter Notebook. Yeah, so let's say a is an integer. Let's say you're expecting an integer input, let's say, and then you write if, or let's say b is again an integer input maybe, and let's say if a is greater than b, then print a. That's it, that's your program. Remember this indentation, I have not written this print here. This is the indentation that defines the block of a. Let's say if I want to print a, then I want to print, let's say I am still inside if condition. And so whatever that starts from this, whatever that starts from this alignment, if I write something here, let's say x is equal to 5, all that block is called the body of the if condition, if it starts from this alignment. If, however, I type a statement, but I type that statement in that kind of alignment, the alignment like this is no longer inside the if condition. So for example, here I type I am outside the if condition. So the purpose of writing these multiple lines is just the if condition does not require to contain only one line of code. It can contain a whole block of code, multiple lines of codes. So this is no longer inside the if condition. So now we will take input A, input B, whatever the numbers will be. If the value in A will be larger than B, then this will be printed and this will be printed. Once these two are printed, then this has to be printed regardless of the values of A and B, because this last print statement, it does not depend upon the values of A and B. It has, the if condition has no impact on that. That is just a sequence of statements. The if condition, the statement inside the if are just these two. For example, if A is not bigger than B, then neither this will execute nor this will execute, but this will still execute because this has nothing to do with if condition. So let's run this code and see how it works. So let's say the value of A. See the power of descriptions. If we could have written a description, then the description could have appeared here. But let's say this is the value of A, let's say 12. The value of B, let's say 10. In this particular case, because the value of B is 10, the value of A is 12, 12 is bigger than B, if this condition is true, this statement becomes true. Whenever this condition becomes true, you are inside the prints, you are inside the if condition. Now this print executes and you get 12. This print executes and you get I am still inside the if condition, and this has to execute no matter what the values of A and B are. So now let me rerun this and give other values of A and B. Let's say the value of A is 10 and the value of B is, let's say, 45. Now this condition becomes false because 10 is greater than 45. This is not true, this is false. So whenever this condition is false, you never land inside the if condition and you go out from the if condition. So these are the statements that are inside the if condition. They cannot execute because you never visit them. They can only be executed if the if condition becomes true. So then once you're out the if condition, that's the statement that is going to be executed anyways. So yeah, so that's the flavor of if condition or decision making. And this is the comparison operator that returns a Boolean value. You may have different kind of comparisons here or combination of comparisons here, no problem, depending upon your logic. But the question is, are we done? We are going to print only the bigger number. We have we have printed the one that is, if A is bigger, we have printed that. What if B is bigger? We have not solved the task yet. This is the task, we have not solved the task yet. So how to do it? Okay, so yeah, it looks like complicated. How to print only that number that is bigger. So if B is bigger than A, then we will print B. Maybe we should apply another if condition. If B is bigger than A, then print B. If A is bigger than B, then print A. Maybe. Yeah, why not? So for example, let's go to Jupyter Notebook and write the following. Let me write a whole new program here. A equals int input. Okay, let's do not have a message. Int input, and then if A is bigger than B, then print A. Okay. However, if B is bigger than A, then print B. I guess we are done. If this condition becomes true, then we are here. And we know if this condition becomes true, then this condition cannot become true, because it cannot happen that A is bigger than B as well as B is bigger than A. This cannot happen. So whatever the bigger number will be, that will be executed. Further, you can see I have this if condition and this if condition. They are aligned in a way that this if condition is not, the second if condition is not inside the body of the first if condition. We will see such cases when this is required, but right now I guess we are done. If A is bigger than B, then print A. If B is bigger than A, then print B. And only one of these if conditions will become true, because A is bigger than B, B is bigger than A. These two statements cannot be true at the same time. So let's see. So A is 10, B is 45. So the answer is 45. Wow, because 45 is bigger. So let's run it again. So A is, let's say, 22, B is, let's say, 4. And the result is 22 because 22 is bigger. I guess we are done with the task. We have used this if condition twice to achieve the task, to print the number that is bigger, and both the numbers we took both the numbers from the keyboard. Yeah, I end this video here, and in the next video I will tell you more features of this if condition, particularly the else statement. What we have done recently with another if could be achieved through an else statement that is more powerful, more readable. So in the next video I will talk about else statement, which is a part of if. So hope to see you in the next video. Okay, in the last video we saw if condition, and we actually had an example in which we wanted to just print the greater number. So we input a number A, we input a number B, and if B is greater than A, we printed B is greater than A. Then we applied another if condition to check if A is greater than B, then print A. The else clause, or the else part of if, is as the name suggests, if this condition is true, if this condition is true, this particular condition is true, then go there. If this is not true, which means else, if this is true, then go there, else go there. So if this is true, then you land here. If this is false, then you land in else part for sure. And this else is, if B is greater than A, if that condition is true, then you print this thing. Otherwise, A might be greater than B or A might be equal to B. Either way, you land in else part. So this if and else, they both have this alignment, but then the block of else started from this particular alignment. Maybe you have more statements here. The alignment of this if block started from here, and you may have more statements here. So let's go to Jupyter Notebook and see the else running. So let's say a equals int input, and b is b is int input, and we say okay, if a is greater than b, then print a, else print b, else print b. Now b will be printed even if it is equal to a or if it is greater than a. Either way, b will be printed. So let's just see, let's just run this and see what happens. So shift enter, so input a number. So a is, let's say 10, and b is, let's say 12. So what do you think? When I will press enter, what will be printed? B or a? B. Yeah, b is printed. That's what b is printed. Now if I run this again and a is 10 and b is 10, still the 10 will be printed. So let's modify. Let's just say dot print if part. So that means we landed in if part. Otherwise, we landed in else part. So just to be more elaborative, let's say so 10 and 10, and we landed in else part. And the reason is if a is greater than b, so 10 is greater than b, 10 is greater than 10, false. So you go to else, and the else block, the whole block just executed. So that's what else is. It's really very nice to have an else there. If this is false, whatever that condition is, if that is false, then you land in else. So yeah, that's else part simply. Now okay, so we have this if else structure. We can have one more power with this if. What if we want if b is greater than a, then you print b, else if a is equal to b, then you print they are equal. And if this is false and this condition is false, if both these conditions are false, then you go to else part. So basically if, else if, else if, else if, else. So you can have really deep structure. For example, in this particular example, if b is larger than a, then you land in this part. Else if, this if is just short form of else. Else means b is not greater than a. Else, you can have another check. Else if a is equal to b, then do what? If we can have one more check, we can have one more check, we can have several checks, and then else. Else will only execute if all the if conditions or else if parts on top, their conditions, they are false, and only then else will be execute. So let's see these else if running on Jupyter Notebook. Okay, so let's say a is int. So rather than taking inputs, let's say a is 1, b is, let's say 5. Let's say we have taken these inputs, a is 1, b is 5. If a is equal to b, then do what? Print equal elif, which means else if. Now, because this is if, you have to write a condition here which will be either true or false. If A is larger than B, then do what? Then print, let's say, A, and else, let's say, you print B. Okay, so that's it. And this statement, print, is not in if condition, not in if. This is outside complete. This is complete if condition with all its else and else if parts, and this is no longer inside. So let's run this. What do you think? What will be the result? If A is 1, B is 5, then else part is going to be run, because A is not equal to B. A is equal to B, that's false. A is larger than B, that is also false. So you will land in else part, and B will be printed, and then a statement will be printed which is not in if. So yeah, so B is printed and not in if. If B is 10, then what will happen? A equals to B, that is false, so you will not land here. Else if A is larger than B, true, you will land here. Because you land here, else will not execute. So A will be printed and then not in if. If A is 10 and B is also 10, let's say, then you have equal. Yeah, so that's else if. Okay, so that's about if, else if, or short form is elif, else structure. In the next video, we will be talking more about this if, else structure in a bit more detail, and we will also be giving you a short form of this kind of else if, else if structure. So hope to see you in the next video. Okay, one way of writing this if, else kind of structure, there is a short form as well, which is written down here in this green color, for example. This is kind of a same code that we saw in the last video, but that's the short form. Let's say A equals 9 and B equals 10, then print A if A is larger than B, else print this particular thing if A is equal to B, else print that. This is exactly the same kind of structure. For example, print A if A is larger than B. So you just read that if A is larger than B, then print A. Else, if A is equal to B, then print equal. Else, print that. So that is kind of a short form of writing this if, else kind of structure. But I will recommend to use, the structure in this particular horizontal form rather than writing that in this particular way, because this kind of structure, that horizontal kind of structure, is much more readable, much more manageable, and this structure might be confusing sometime for some kind of readers, and also if this structure goes on and on and on, which we will see in an example today, writing very deep and lengthy structures in short form is not very feasible. So but this feature is there if you like to write if, else kind of structure in this way. This is available in Python. Okay, let's get a good grip on this if, else structure on Jupyter Notebook. Let's move on to Jupyter Notebook to see an example, just an example. So let's say the example is user will input a number, let's say int input, let's say, and enter marks, let's say enter marks for a particular subject. Let's say user will enter some marks, and our goal is if the marks are larger than 85, then we will print A grade. If the marks are larger than 80 but smaller, so if the marks are larger or equal to 85, then we will print A grade. Else, if marks are larger or equal to 80 but smaller than 85, then we will print A minus grade. And if else if marks are larger or equal to 75 but smaller than 80, we will print for example B grade, for example B grade, and so on. And let's print this whole nested structure. That let's make this else if kind of structure a little lengthy. Let's get comfortable with it. So if A is larger than or equal to 85, to enhance readability, it is good to include a space after the variable and space, but don't actually write the space inside that, because larger and equal to, they combine without space, is an operator. So if A is larger than 85, then print, let's say, A grade. Grade. L if A is larger or equal to 80 and A is smaller than 85. So let me write this in a more readable form. Else if A is smaller than 85 and A is larger or equal to 80, then we should do what? It is sometimes good to include these kind of parentheses. Sometimes it is good just to make these things more readable, that this is one block, this is one boolean, this is one boolean, this is one decision, this is one decision. Although not writing the parentheses is also okay, but writing the parentheses make code a little more readable. So for example, if A is smaller than 85 and A is larger than 80, if that is true, so remember and is true only when the left side is true and right side both are true, then this whole condition becomes true. And I promised you that I will show you the power of comparisons and actually combining the Boolean variables using ands and ors and stuff like so. So here you're seeing the one. In that case, let's say print let's say A minus grade, and elif if A is smaller than, if A is smaller than 80 and A is bigger or equal to 75. If that's the case, then what should we do? Let me omit the parentheses just to show that whether writing parentheses or not writing parentheses is perfectly okay. I just recommend to write parentheses so the code becomes much more readable than otherwise. Okay, then we have print, let's say B grade, and let's say one more elif if A is smaller than 75 and A is larger or equal to, let's say 70, then print B minus grade, let's say. And let's just finish this. Let's else print below average, for example. Let's say that's our code. So we will enter numbers. If the number is greater than 85, then A grade. If when this condition becomes true, then this print will execute and we will out of the structure right there. If this condition is false, then this condition will be checked. If this condition becomes true, then this print will execute and we will be out of the structure. If this is false and this is false, then this will be checked. If this is true, then we print B grade and we are out. But if this is false, then this will be checked. And if this is true, then we will print B minus grade and we will be out. If this is also false, then we will dive into else part and we will say, okay, below average. So let's see, for example, let's say the marks are 82. So A minus grade, yeah, that makes sense, A minus grade, because the marks are smaller than 85 and larger or equal to 80, so A minus grade. Yeah, let's run this again, and we have, let's say, marks, let's say 64, below average. Okay, great. So you see this if, elif, else, this can go as long as you want depending upon your logic. So great, and further you can combine several comparisons, several booleans together with ands and ors and nots, whatever you like to do. Let me give you one more beautiful thing. Let's create an else without writing an else. Let's just write elif and implement else, completely else. So we are not going to write else explicitly, but we are going to write a program that actually simulates else. So let's see, if A equals, let's say, 3, if A is larger than 10, then print, let's say, larger than 10. Now we are not going to write else, but we are going to achieve the else part. If not A is greater than 10, you see, then print else part. You see that? I mean, that's beautiful. If this condition is true, then go there. If this condition is false, then not of false is true, then you land here. And you need not to write an else part if you want. Just I have implemented else part using elif. So see that? So else part. So we are in else part. If A is, let's say, 13, then we will print, okay, greater than 10. Oh, just for fun. Okay. Okay, great. So we saw if condition, its shorthand, and else if structure in a bit more lengthy way. So in the next video we will see if condition inside or in the body of another if condition, which is called a nested if. So hope to see you in the next video. In the last video we saw if else if structure. In this particular video we will see nested if, or simply called if inside the body of another if. So let's take an example to understand what nested if condition is. Simply we can understand if condition inside another if condition, that's all. Rest of the story is the same. The way if works, it works even if it is inside the body of another if, or anywhere actually. So let's say we have input a number and then we check if x is larger than 10, then you move inside the if condition, if that is true. If that is false, then you are here, whatever you write here, it will work from here. But let's say x is greater than 10, then you print your number is greater than 10, your number is above 10, let's say you print that. Now after this statement, you move to this statement and you just make another check. If x is larger than 20. Now you see this if condition, this particular statement is inside this particular if condition. If this condition becomes true, only then you dive in, otherwise you're not. So here you're checking if x is larger than 10, then you move inside, and inside you're making more checks. So for example, if x is larger than 10, then you print or do some stuff here, and then you apply further more checks, more granularity, more whatever your logic is. So let's say here you are checking if x is larger than 20. Now if this condition is true, then you move here, else. Now this else is of this if. If x is not larger than 20, then you move to this else, else part and you're here. So, and we can have another if inside this particular if, or an if inside this else part, and so on. So if inside an if is called nested if, and we can have deep structures, for example, if, then something, then if, then something, then if. So maybe we can have a very lengthy structure, if nested if structure, depending upon the logic. So let's get ourselves comfortable as always by writing the code on Jupyter Notebook, because that makes much more sense when we see things running on the notebook. So let's say A is let's say again int, let's say we take some number, and if A is larger than 10, then we say okay, print larger than 10, and do more stuff. Print, let's say, inside the top if condition. Okay, then maybe we have another check. If A is larger than 20, then say print greater than 20. Greater than 20, and you can print now, print inside the nested if. Okay, else print smaller or equal to 20, and then print, for example, inside the else part of nested if. That's it. And you can print here, print outside all ifs. Fine. So that's it. That's a structure. So let's see. Let's give an input which is larger than. By the way, if input is not larger than 10, this if condition is false, then you directly dive to this print statement, and all this structure is not going to be executed. This complete thing is called the body of this if condition, and the body will only execute if the condition becomes true, whether that condition is just a single condition or you have a combination of a lot of comparisons and a lot of booleans, whatever. If this condition becomes true, whatever that condition takes form of, then and only then you dive into this part. And when you're in this part, then that's a whole new universe. Then you're on its own in the new part. In the new part, for example, if this condition becomes true, then you are in this part. That's the body of this particular if condition, and that's the body of the else part. See, the body of the top if condition has this kind of alignment. All the statements that are in the body of if condition, they start in the same alignment, and all the conditions, all the statements that are in the body of this particular if condition, they have their own alignment. And this indentation is necessary just to define, for example, which statement is in what kind of block. For example, if I just press a tab, then another tab, then this print statement is in this else part. And this is the indentation that is defining the placement of this print. If, for example, I press, I align this with this, this particular structure here, then this print statement is inside this if condition. This is the indentation that is defining the placement of different statements. And if the print starts from here, then it is completely outside of all if conditions. It is like this way. So let's run this code and see what happens. Let's say we print, let's say we just write A equals, let's say 12. So what do you think? What should be printed? If A is 12, then first of all, this condition is true. So greater than 10 will be printed inside the top if that will be printed. Then this check will be executed and this condition will become false because 12 is not larger than 20. Then you will go to the else part, and less or equal to 20, this string will be printed, and then inside the else part of nested if, that will be printed, and then you will be out of all if conditions and outside of all ifs, that will be printed. So let's see whether whatever we have said is correct or not. So yes, greater than 10 inside the top if, less or equal to 20 inside the else part of the nested if, outside all ifs. Yeah, so that's what the nested if is. And by the way, you can have for example more if conditions inside the nested ifs. For example, you can have one more condition here. If a is larger than 30, for example, then do what? Then print it is larger than 30 as well, and further print, maybe not necessarily that you always write print statements, you can do any interesting stuff inside inside the nested if of nested if. Fine. And then you can write the else part of this particular if condition here if you want to, or whatever. I mean, you can have as hilarious structure as you want, but that completely depends upon the logic. Or you may have an if condition inside that else part here. For example, you can write an if condition here if whatever. That is also perfectly fine. So if a is larger than 20, then you print this. If a is larger than 30, then this, for example. And let me write the else part here. Else print less or equal to 30, and we can print inside the nested, inside the else part of nested if of nested if. Okay, so wow, you see that program? Let me just scale it down so that you can see that completely. See that program? I mean, yeah, it makes perfectly sense to me. For example, you take an input. If that is larger than 10, then you're here. If it is larger than 20, then you are here. If it is not larger than 20, then you're here. Okay, so let's say it is larger than 20. If it is larger than 20, then you're here. Further, if it is larger than 30, then you're here. Otherwise, you're here. And by the way, if a is not larger than 10, then you're directly here. Wow. So let's run this code. Let me just scale it down so that you can see it more. You can see more text, let's say. So let's run this. No errors, great. So let's say the number is let's say 25. So what do you expect the result? So the number is 25 is greater than 10 inside the top if. It is greater than 20 inside the nested if. It is smaller than or equal to 30, so inside the else part of nested if, and then outside all the ifs conditions. Great. Yeah, you enjoyed that? I enjoyed that. Great. Okay, so that's about the nested if. One more thing that I have already told you, but just let me tell you the power of indentation. You are here, for example, in this particular if condition. That's the if condition, and that's the nested if, and that's the else part of this if. If you move this else part in the indentation or the alignment with this if, then this is else part of this if, and this is not the else part of this if. So remember the power of indentation. This is the indentation that defines which part belongs to what kind of block or structure in Python. In other languages, sometimes, for example, in C++, they normally use to write these curly brackets to define a block, and their indentation doesn't really matter. But in Python, this is the indentation that actually defines each and everything. So for example, this is a crucial example. If this else just moves backwards and aligned with this if, you get this else with this if. These are two if and else structures. This is still nested if without an else part. And if this else move somewhere in between, I mean, if this is not aligned with this if, this is not aligned with this if, you get a syntax error because that is not a proper indentation. So focus on indentation. That is really, really important. Yeah. So although I've told you that the indentation has already told you, but I just found to make a slide over this else part because that's important. Sometimes you may get confused whether this else belongs to this if or that if. Well, the indentation defines this else belong to what. Okay, I end this control flow indentation here. So from next video we are jumping toward loops, but before loops I just want to write a lengthy program in if, else if, their combinations. I just want to write a Jupyter program for you to get comfortable with if, nested if, the conditions that are ands and ors and nots or stuff like so. So in the next video we will be practicing more on Jupyter for if conditions, and then from the next to next video we will be jumping toward loops, the very, very powerful structure. Okay, hope to see you in the next video. Okay, so let's just practice this if condition a little bit more. In this particular video we are going to achieve a particular task. So let's design some task here. By the way, this is comment. Comment is it starts from a hash symbol, and that's a statement that will never be executed. This just describes your code, for example. So it is not there, but it is there as a text but not as a code file. Like hash sometimes represents comment or description with a single line. If your comment goes on multiple lines, it is good to write a multi-line comment. So that's a single line comment, for example. Single line comment. The multi-line comments, they start with 3 quotes and then end with 3 quotes. So whatever you write inside in these in this particular block, that's a multi-line comment. So let's describe our problem in this multi-line comments, because that's the problem in form of text, and then we will be solving that problem using the code. So that's just description of the problem. Let's say user will enter a floating point number, let's say 238.915, let's say. Okay, your task is to, so let's just more readable. Your task is to find out the integer portion before the decimal, before the point, let's say before the point. In this case it is 238, and then check whether if that integer portion is an even number or not. So just print yes or no. So print even if it is even number, otherwise print odd. So that's the problem statement. That's the problem that we are going to solve. And this is just comment. Now we are outside the comment. That's a multi-line comment. Yeah. So how to solve that problem? Yeah, how to solve that problem? So let's start solving this problem. I'm going to spend some time on this program just to get comfortable with the if conditions. Let's say that number is x is input. Let me convert that input, enter a real number, let's say. Okay, we are just assuming that the user will enter a real number. It's a real number. Real number might be, 238.0, that's a real number, or 238 itself, that's also a real number. That's okay. But we are not assuming that the user will enter, let's say, some characters like ABC or stuff like so. Just assuming that. Okay. Now, assume that x contains a real number. It may be an integer by default. Maybe user just enters 10 and that's it. So it may be already an integer. Then we have to check whether that 10 is even or not. Or the user may enter 11.7, or the user may enter minus 34.7, or the user may enter just 0, or user may enter just 0.35. There are a lot of possibilities that the user come up with. This x can contain any kind of number, and we have to check according to. So how can we move? Let us just see whether that number, let us just extract the decimal portion, the portion before point. Let us just extract that. How can we extract that? There are two conditions. First of all, let's see, if x is positive, then do what? Else do what? So let's write this structure first. If x is positive, then what we have to do, and if x is negative, then what we have to do. So if x is positive, then what we do, we just so what should we do? I'm just stuck here. How can we extract the decimal portion, the portion without this particular thing? How can we extract that? That's tricky. That's kind of tricky. Yeah. So any ideas? I guess this the structure I'm using. Let us just first think that x is positive. Just make our life easier, and then if x is positive, it's a positive number. How can we extract this portion out? Just the number that is below, that is before the decimal point. What should we do? Can we apply a round function? Will that help? X, will that help? Helps? Yes or no? Round function. So let's say y contains the rounded value of x. Then so what? Then how can we extract the decimal portion, the integer portion? Or maybe there is a function that actually round downs. Let me check whether there is a function float or not. No, float is not a function, I guess. So let's say round x. Okay, now y contains the rounded value of whatever the x is. We are now assuming that x is positive. Okay, then what? Now if y is larger than x, that means we moved up. Okay, we moved up, the round goes up. In that case, what we do is we just subtract we just subtract the integer portion. So the integer portion, let's say that's our variable name. Then the integer portion is simply y minus 1. Is that correct? Is that correct? If y is larger than x, then integer portion is simply y minus 1. For example, just think about it. If when for example, if the value was 29.6 and the rounded value will become 30, so 30 minus 1 will be 29. That is what we are interested in. So yeah. So otherwise, if, for example, else if y is not larger than x, then y itself is an integer portion. Y itself is an integer portion. Is that correct? I mean, is that making sense to you? That if, for example, if x is larger than, if the rounded value of x is larger than x itself, then we just subtract 1 and we get the portion. Otherwise, the rounded value itself is the portion. Let's just run this code for now and check whether whatever we have done so far is correct or not. So after that, just print, let's say, the integer portion. Let's just print that. Okay, so enter a number. Let's say the number is let's say 25.367, let's say. Obviously the integer portion here is 25. So let's see our program returns 25 or not. Oh, the result is 25 magically. Oh my god, we found 25. Let's run it again. Just to see okay, let's run this again, and this time let's give it to 45.8. okay, the integer portion is 45, but when we will round we will get 46, and 46 minus 1, we will dive into this particular if condition. Let's see. Oh, the result is 45. We are still moving very well. Great, that's great. So okay, let's play with it. Let's give 0.2. The result should be 0. It is 0, right? Let's run it again and give it, let's say 4. That's it. The result should be 4 now. It is 4. Great. So we are working very well. We have extracted the integer portion as long as the number was positive. Okay, great. What if the number will be negative? Let's say that was true. If that was true, so that whole logic works if x was positive. So if x is positive, then whole this logic just works. Okay, then else, what should we do? If x is positive, then this logic works. If x is not positive, then what will happen? Then how can we find out the integer portion? Because first we have to find out the integer portion, and then we have to find out whether that integer portion is even or not. Finding out whether that integer portion is even or not might be simpler, but first we have to find out the integer portion. So for example, let's check the behavior of round function on negative numbers. Let's say round minus 9.3. So the result is minus 9. Okay, if we say okay, round minus 9.6, the result will be minus 10. So it looks like the same as working in the positive numbers. So round function is actually working roughly the same way it should work in the positive numbers. Okay, so what should we do here? Any idea? Maybe we first convert by the way, yeah, maybe we first convert the number, let's say y equals round x again like before, but then what? So maybe this rounding helps the same way. Maybe the rounding helps the same way. We should extract this x out from this here, because it is going to work in the else part as well. Why to compute it? Why to write this redundant code? So y is round x, let's say. Then if y is greater than x, what should we do? If it is negative, y is greater than, then what will be the portion? It will be, the integer portion will be what? Y minus 1 or what? Y plus 1. Yes, you got the answer. That's y plus 1. Great. And else, I guess we have integer portion equals y itself, I guess. Yes, I guess that's the code. That's the code. I guess. Let's check, by the way, but I guess that's the code. By the way, this else part is same in both of these conditions. So maybe we can combine this code and write a more elegant code, but I guess this will work. Let us just print the integer portion just to check whether we are working well so far or not. So let's enter, let's say 12.3. The result is 12. Great. So it did not change our previous, I guess, our previous logic. So let's say there is minus 9.8. Now the integer portion should be minus 9. Oh, it is returning 10. Why is that? Why is that? Oh my God, this should be changed. When it is round, it may go that way. When it rounds, it actually becomes lesser than 10, because when it rounds, it goes up and it becomes lesser than. In negative world, this condition should flip. Yeah, so we are making an error here. Let's fix that. Okay, let's run this again and see. Let's say minus 93.2. Minus 93, great. So then we have, let's say, let's run it again, minus 8.9. Minus 8. I guess we are working perfectly fine. Once we have integer portion with us, we just write here at the very end, if integer portion remainder with 2, if that equals to 0, print even, otherwise else print odd. That's it. That's the whole program. Let's see, and let's see how is it running. Let's say 22.6, it's even. Let's say minus 87.3, that's odd. Great. So you see the power of if condition and how can we think in writing these programs and stuff like so. That was a lengthier video, I know, but I guess you get a very good look and feel of if conditions and thinking and building a logic and all that stuff. So in the next video we will start loops. So that's a beautiful structure. Hope to see you in the next video. The best way to understand loops is to think about in a repetitive structure or repeating structure. Let me give you an example, and we will dive into this code in a while. The example is, let's say a user gives you a number, let's say integer number, and you want to print all the numbers till that number. Let's say you start from 1 and you keep on moving and printing all the numbers as long as you reach that number. So for example, if user enters, let's say 5, your goal is to print 1, then print 2, then print 3, then print 4, and then stops. Then stop, just stop. Or let's say if user print, if user enter, let's say 3, then you print 1, you print 2, and then you stop. This is easy. If user enters an n, we can just print, we could have written this thing, print I. Let's initialize a variable I with 1, print I, and then I equals to I plus 1, or in Python we can write this quickly as I plus equals to 1. That means that means in I store I plus 1. This is the short form of writing this. And then after that, you just apply an if condition. For example, here you can apply an if condition and say, okay, if I is smaller than n, you keep on printing, and after printing you just increment again this, then check the if condition and keep on moving. Well, that is feasible if n is 5 or n is 3. What if n is, let's say, 50,000? I mean, you're writing all that structure again and again and again. I mean, that's a whole lot of code. Well, the loops are just a solution of this kind of structure. When you want to perform same kind of task again and again, the loop gives you the facility to do that. For example, let's just consider a while loop. This is again a condition similar like a condition in if condition. Like in if condition, you evaluate this Boolean expression. That's an expression that results a Boolean value. While this condition is true, you will stay in this block. And after executing whole block once, you check this condition again. If this condition is again true, you will dive into this block again, then check the condition, dive into the block, then check the condition, dive into the block. As long as this condition stays true, you stay in the block, you move inside the block. Once this condition is false, then you exit this while loop, then the loop terminates and you move on to the further processing. Just like in if condition, just like if conditions, if the condition becomes false, you exit that if condition and you go moved on. So in this particular case, for example, if n is 5, let's say if n is 5, user give an integer number that is 5. I is equal to 1. Now 1 is smaller than 5. The condition is true. You move inside. You print I. The value of I is 1. So that's what you print. You print 1. Then you change I. You increment I with 1. That means I equals I plus 1. So I becomes 2. Now the body of the loop finishes. That's whole body of the loop. The body of the loop can have many statements, a whole block of code. Once I becomes 2, you move on and you check, okay, 2 is smaller than 5. Yes, it is true. You move inside the block again. You print 2. Then you update I. The loop body finishes. Once the loop body finishes, you go and check the condition again, whether that condition is still true or not. It is still true. The I is 3. 3 is smaller than 5. Yes, you move inside. You print 3. You update I. You check the condition. 4 is smaller than 5. Yes, you move inside. You print 4. And then you update I. And then you move on. Now 5 is smaller than 5. False. Once the condition is false, you will not dive into the body of the loop. You will exit the loop and you will print done. And that's it. Done. So this loop becomes very handy in applications that have repetitive structures, and in most of the interesting programs, most of the interesting problems, these are the loops that play a very huge role. So let's go to Jupyter just to get our hands on this loop. For example, let's say x is again, let's say int or n. Let's take n. N is int input. Let me make this a little bigger, just to, let's say that input, and input is a number. Let's say n. I is your certain, let's say 1, while I is smaller than n. You may have written this parenthesis just to create the readability, just to make the readability, and otherwise, I mean, this is also okay. That's perfectly fine. As long as I is smaller than n, keep doing the following. What you do is print, for example, the square of I. Print the square of I. That's a square of I, let's say. And then you say print, for example, this is iteration number, and then you just print I. That's the iteration number I of the loop. That's the iteration number I. This is just a string. This is just a string. and that's a variable. Its value will be printed. This print function takes as many arguments as you pass. So you can write a comma here and continue whatever you want to print. That's a very flexible function. Okay, then what you do, you say, okay, I plus equals to 1. By the way, this I plus equals to 1 is the same as I equals I plus 1. You see, I have just commented here just to explain what this is doing. If I just write I equals I plus 1, that is also correct in Python, but that's kind of a shorthand. Okay, and that's it. Now again, when I de-indent, I'm outside the loop. This is print loop done, for example. So that's the code, for example. So let's run this code. For example, let's say n is equal to 5. Then we have 5. So this is 1. This is the iteration number 1. Then 2 square is 4. This is the iteration number 2. Then 3 square is 9. The iteration number 3. Then 4 square is 16. This is the iteration number 4. And then the loop finishes. That's it. That's a first snapshot of the loop. We will continue from here onwards in the next video, and I will show you more and more flavors of this loop. So hold on and wait for the next video. Okay, in the previous video we saw while loop, and we saw one program related to while loop, just printing a bunch of numbers till a particular number. Well, when you are inside the body of the loop, that's a whole new, you can write whatever you want to write. For example, you can apply an if condition inside the body and check that at each iteration a particular decision should be made or not. For example, in this particular case, I'm going to print I whenever I is an even number. So I is some number. If it is even, then print it, else pass. This pass statement, for example, is just a statement of saying that do nothing. It is just a shortcut of writing do nothing. We could have omitted the whole else part along with this pass, and still the code is equivalent. But sometimes writing this pass make the code readable. Just so writing this pass statement just means do nothing and just move on. If we omit else statement and we omit this parse, that's perfectly okay. So for example, let's try run this code. Let's say n is 5. I equals 1. 1 is less than 5. Yes. 1 is not an even number. So go to else part. Else means pass, which means go on. And then increment I. This print statement is outside the loop. This is aligned with this while. This is not inside the body of the loop. Otherwise, it should have been indented inside. Now I is incremented. I becomes 2. Now move back. 2 is smaller than 5. Yes. 2 remainder 2 is 0. Yes. So print 2. So 2 will be printed. Because if executed, else will not execute, and I will increment. Because I is not inside the if condition, it is inside the body of the loop. So I incremented, I becomes 3, you go back. 3 is smaller than 5, yes. 3 remainder with 2 is 0, false, so pass. I plus 1, so I becomes 4. 4 is smaller than 5, yes. 4 remainder 2 is 0, yes, so print 4. So else will not execute. Now increment I. Once you increment I, you get, for example, I equals 5. Now 5 is smaller than 5, false. So you go out of the loop and you print done, and that's what this code is. So you can have if condition inside the loop. You can have nested if inside the loop. You can have loop inside the loop, nested loops. We will see examples of nested loops as well. I mean, that's all allowed or sometimes really required. Okay, so next there are two important statements that are there. One is break, one is continue. I want to focus these statements because they have a deep link with loops. A break statement, wherever written inside the body of the loop, tells that exit the loop immediately. Whenever this break is encountered, whenever this break executes, it exits the loop immediately and brings you outside the body of the loop. That's what it does. Break. So for example, if I becomes divisible by 17 and the remainder becomes 0, you will print a break. And then when this break statement will execute, you will exit the loop immediately, regardless of what is the value of I, what are other states, whatever. Break exits the loop. Okay, great. Now the continue. Continue statements. Continue statement wherever encountered. Continue brings the next iteration loaded, regardless of the remaining statements in the loop. For example, when this continue will be executed, no matter how many statements are there onwards that are there in the body of the loop will not finish its iteration by going through all the remaining statements, but it will start another iteration immediately. So continue basically skips the remaining body of the loop and starts another iteration. Here I have written this true. True means, while true means always run. You might be thinking always run, it's an infinite loop. When we will exit the loop, because this true statement will always stay true, we're not changing this true anymore. There is no condition here, that's true. While true means always go inside the loop, but whenever this break is encountered, you are outside the loop right away. And this break exits the loop. This continue skips the remaining portion of the loop body and starts the new iteration, starts another iteration. So this continue means start another iteration immediately, skip the rest of the statements. So rest of the statements inside the loop body. Okay, so let's just practice this break and continue just in Jupyter Notebook to get a better look and feel of the loop. So let's say we have, let's say n equals, let's say 10, or we might have taken that as an input. Let's say n is equal to 10 while true, which means keep moving. We might have taken some value here, I equals, let's say 1, while true, if I remainder with, let's say 9, if that is equal to 0, then just break the loop. Else what you do is really you increment. Else what you do is if I is not divisible by 9, then what you do is I equals I plus 1. That's true. By the way, previously we have written this way, so either way is fine, whether you write a short form or this form. So else this. Okay, and that's it. The loop finishes. That's the loop. After the loop, you just write okay, print the loop is done. So let's see what's the output. The output is done straight away, and the reason is why it is, oh, 1 is divisible by 9, only then you could have break. While true, why the loop, oh, it does not print anything. We could have printed some statements so that we know that we went inside the loop or not. Okay, so inside if, so for example, print inside else. So let's run this again. Oh, okay, great. Inside else, inside else, inside else, inside else. The first time it go inside if, that time it breaks and it goes out and prints done. That's what this break statement does. So let's see an application of continue statement. Let's, for example, just copy and paste that code into another cell and see how this continue works. So let's say we have a loop like so. So what we say is like this: if I is 9 is not equal to 0, if this is the case, if I is not divisible by 9, what you do is you take I plus equals to 1 and then continue to the next statement. And whatever else you write here, for example, print something, print something else, whatever, that will not be printed. And once the continue will be encountered, whenever this I is whenever this I divisible by 9 is not true, if I is, then you continue. Once this I is divisible by 9, for example, then you will not dive into this if condition. Only then these two statements will be printed, because this continue will not allow anything further that should happen. And once these are printed, let's say we break our loop right there, let's say. So if, for example, for the very first time 1 is not divisible by 9, so I equals 2, so continue, these three statements will not be executed, the next loop, the next loop, the next loop. Once this if condition becomes false, this continue will not operate, and then we print this statement, then only then we will print this statement, and only then we will break and we'll exit the loop and print the done. So let's print here, print inside if. So let's run this code. Let's run this code and see what happens. That's the code. Maybe I should just, yeah, that's a better font. Let's run this code. So when the code is run inside if, you see when you are inside if, when you continue, when this is the body of the if condition, when if condition completes, it should print these two things. But continue is telling the cursor to go back to the next iteration and move on. And once this if condition becomes false, only then you get this thing printed, this thing printed. If this break was not there, you then again was going to the while loop, and you will be running an infinite loop, and then you have done. So that's what this continue and break does. So in the very next video, we will see another kind of loop. Here we saw the while loop. In the next video, we will see a for loop. Very powerful and very famous kind of loop. For it does almost the same stuff as while loop. While the while loop runs based on a condition, the for loop, it runs based on counter. It's a counter loop that many times it should run, and so on. So we will see the details of for loop and the applications of for loop in the next video. Hope to see you in the next video. Okay, in this video we are going to discuss for loop, another kind of loop. In the previous video we saw while loop. Although most of the stuff, almost all of the stuff can be achievable through while loop, but sometimes it becomes handy to apply for loop. In this particular example, I'm going to populate a list. So before actually moving towards for loop, let's see very shortly what a list is. Although we are going to explore this list in much more detail when we will discuss the data structures module, but just for the sake of example, a list is a collection of different kind of elements. For example, 2, 3, 4, that's a list of 3 elements. So 2, 3, and 4. The list can contain different type values, for example 2, 3.4, and stuff like so. We can access different elements. For example, L of 0 means the very first element. The indexing, this is called the index. The index starts from 0, then index 1 is. So if we print, for example, print L of 0, the result that will be printed will be 2. Similarly, we can append more values, inside a list, append, let's say 53, and the list, after this append operation, the list will be having these values 2, 3, 4, 53. We can remove, delete, update, and do a lot of stuff. We will see lists in detail, but just for this example, just think that list is a collection of a lot of elements, and we can add, insert more elements, we can delete elements, we can change elements, and so on. Or we can just initialize the list with just an empty list and start inserting elements one by one and expanding that list. Okay, now this is an empty list, for example, and for I is just a variable. For I in this range is an iterator. Range 10 means sequentially give a number one by one starting from 0. Start from 0, give numbers one by one. For example, first time give 0, I will contain 0. Second time give 1, third time give 2, and so on. After every iteration, the range will give another number as long as the numbers, they are smaller than 10. So the last number that this range will return will be 9. So whatever this is written inside is not included, and it starts from 0. So as long as I is in this range, I is lower than 10, as long as that's the body of the loop, just like the body of the while loop. So first time I will be 0, and 0 is smaller than 10. Okay, you print I plus 1 and append the square of that in a list. Then next time this range will automatically return the next number into I. Now next time I will contain a 1. Next time I will contain 2. Next time I will contain 3, 4, 5, 6, 7, 8, and 9. Once the value of I becomes 9, that's the last iteration of this body of the loop, and after that the loop finishes. So let's just write on this. Very first time I will be 0. When the loop enters its body very first time, I will be 0 and 1 will be printed because we are printing I plus 1. At that time, the list and the empty list will be having one number, which is 0 square. So list will be having just one number, 0, because 0 square is 0. Next time I will be 1 and we will print 2, and the list will contain 1 square, which is 1. Next time I will be 3, I will be 2, we will print 3, and we will be having a square of 2, which is 4, and so on till 10 here. When the I will be 9, we will print 10, and in this list we will be having 9 square, which is 81, I guess. And after that the loop finishes and we will be out of this loop. Okay, let's see this. Let's see example of this in Jupyter, just to get more comfortable with the list as well as the for loop. So let's see. Let's say we have an empty list. Let's say an empty list. Just consider a list like this. L is just a variable. You can write another variable name. That's a variable name L. Okay, so for I in range, in is a keyword, range is a function, in is a keyword. I in range, for example, let's say 10. What you do is you print I plus 1, or whatever you want to do. That's the body of the loop. And L dot append, that's a function of the lists. We will see that in detail in the data structure sessions. Okay, and that's it. The loop finishes. When you finish the loop, just print the whole list. So let's say print the list, and you can see the result: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's these are the values in the list, as I mentioned earlier. All these are the values. By the way, this range function actually, what if we want I to jump more than just 1? For example, we want I to start from 0, it reaches 10, and let's say we want the jumps to be taken as 2 rather than 1 and 1. So the very first time, so that's the start location, that's the end location, which is not included. Start location is included, end location is not included, and that's the step size. So very first time I will be 1, you move inside, then a jump of 2 will be taken. The next time I will be, so very first time the I will be 0, then you move inside, then the jump of 2, then you move inside, then a jump of 2, then you move inside. As long as you stay smaller than 10, you will move inside the loop, body of the loop. So let's see what now printed. Let's print just I rather than I plus 1. Oh, there's an error. What's the error? 0. Oh, the range function does not have colons. It has actually commas. Sorry, my mistake. I was just a Matlab user once, so Matlab actually has these colon things. So I was just confusing Matlab notation with this. Okay, great. So first time I was 0. Next time a jump of 2, I becomes 2. Next time a jump of 2, I becomes 4. Then I becomes 6. Then I becomes 8. And next time I becomes 10, but 10 is not included, so you're out of the loop. And that's the squares that you got. It is not necessary that you always start from 0. You can start from 1, and you can take a jump, for example, a jump of 3, and it's not necessary that you just reach 10. You can reach, for example, 20. It's up to you. It's completely your choice. And in that case, you have this kind of iterations. So this range function really is helpful for iterating over a loop body or a structure. Okay, great. So that was introduction of for loop, and we have iterated here on a list. We just have actually populated a list using for loop. Okay, in the next video we will see more details of this for loop and more fun stuff. Okay, hope to see you in the next video. Last time we saw a for loop in the last video, and magically this else has something to do with for loop in Python. Well, this else clause makes sense for if, but in for loop it hardly makes sense. But let me try to make sense of else clause for loop. There is an else part of for loop as well in Python, not in other languages. I don't know any other language that has this else part. Maybe there is some, but I don't know. So this else part in Python, particularly in for loop, this else part or else block will only execute if for completes its iterations. For example, this is a set. A set like a list is a collection. List is defined by square brackets. Set is defined by curly brackets. The set is just similar like the set in mathematics. We will see the set, lists, tuples, dictionaries, and many of these data structures in detail in data structures portion, but just I have introduced this. Just consider this set has 3 elements: apple, 4.9, and cherry. Apple is one object or one data, 4.9 is one data, which is a floating point data, and cherry is one data, which is a string data. Okay, so this S has 3 elements, 3 different elements. So now for X in this set, as long as X is in the set, the very first time the X will be apple, so it will print apple. Next time X will contain a 4.9 as long as, so iterate over this set. As long as X is inside the set, pick elements one by one and just print them all. Okay, we expect that when X is apple, when the very first time X will be apple, it will print apple. Next time X will be 4.9, it will print 4.9. Next time X will be cherry, it will print cherry, and the loop ends because there is no item in set to iterate over. Because the loop finishes its complete iteration, there are expected 3 iterations, and the loop finishes those. Now the else part will execute, and you will say, okay, loop completes its iterations. Well, you will be wondering in what case the else will not execute. If you apply any break statement inside the loop body, which means you forcefully remove some of the iterations that were going to be executed, but the loop did not complete its iterations, then the else part will not run. So let's see an example in Jupyter to get a good grip on this else. Okay, let's define a set. S. S is a variable name. You can have any variable name. Let's say apple, or let's say 4.9, I guess. And then we were having let's say cherry, if these spellings are correct, I guess, cherry. Okay, then for x in s, as long as x is in s, print x, fine, else print when you finish the loop terminates with success, or all iterations, it completed all its iterations. And this is a statement that is completely outside the loop. Outside the loop. So let's run this. So you can see apple 4.9 cherry, loop terminates with success, outside the loop. Okay. Now you might be thinking, in what case this else will not execute. Okay, if for example, as long as x is in n, if I say, okay, let's say I take a counter here, I equals 1, that's a counter, let's say, and every time I just increment I plus equals 1, and then I check if I is equal to 3. If I is equal to 3, then just break, let's say, else, just for readability, else pause. Now this else is else of this for, and this else is else of this if, and this pause statement is just a statement for doing nothing. Now what you do, when I is equal to 1, you print this, I plus equals, I becomes 2, 2 is equal to 3, false, so you pause, you move on. Next time x will print 4.9, I will become 3, and 3 is equal to 3, that's correct. The break will execute, which means the loop should have one more iteration, but the break just disrupt that one more iteration that should be there. Because the loop could not complete its iteration due to this certain condition, this else part of the loop will not execute, and you will go directly outside this loop. So let's run this code and see the result. So you can see this, apple 4.9 outside the loop. I would recommend also this else is there for loop, but I would recommend to avoid using else in the beginning. I mean, you may be confusing this else. By the way, there is a mistake here. This else should be ended with a colon here. Okay, so I would recommend to not use else clause for a for loop in the beginning until you really need it, because you may confuse this else with the else of if condition, and you may think something else and the program behave in a different way. So either way, if you want to use else for a for loop is there in Python. Okay, just one more example of for loop, and here we use dictionary. I'm introducing some data structures here just for fun. We will see these data structures in detail later on. So dictionary, that's a key value pair. It is like a set, but one item consists of two numbers. That's called a key, and that is called a value. That's a key and that's a value. Like a dictionary, we have key and values. So now, as long as x is in x, x represents to key, and d is our dictionary, and d of x represents to whatever value that x points to. For example, apple is a key that points to 44. Cherry is a key that points to game. For example, if I write d apples, apple, the result will be 44. Similarly, d of cherry, the result will be game. Okay, so let's iterate over this dictionary using this for loop. All am I showing you that this for loop is very, very handy of iterating over different data structures and a lot of data and stuff. Whereas while loop is more handy in checking the conditions and stuff. Although you can do all the stuff using while loop, you can all the stuff using for loop, but one is better over the other in certain situations. So let's just run this for a dictionary. Let's say I have a dictionary D. It's defined like a set. Let's say my key is A and my value is 10. Let's say my key is B and value is minus 19, and let's say my key is C and my value is, let's say, ABC. Let's say that's my dictionary. So for X in D, print the key as well as the value of that key. So now you can see the key is A, the value is 10, the key is B, the value is minus 19, the key is C, the value is ABC. So this for loop is really handy in iterating over a lot of data structures and stuff, although it has other applications as well, but this is handy. Okay, great. So that's about loops, for loops and while loops. These are two kinds of loops in important loop. These are two important kind of loops in there in Python. In the next video, I will directly go to Jupyter Notebook, and we will be practicing for this for loops or while loops. We will be practicing the loops. We will be doing actually examples of nested loops. We will be actually solving a problem like we did in the if conditions. We solved a problem previously. We wrote a code for it. Here we will also write a code, and we will get a good grip on the loops. So hope to see you in the next video. We will solve a problem in Jupyter Notebook directly. Okay, hope to see you in the next video. Okay, welcome back. In this particular video, we are going to practice for loops, or basically loops. So let's have a problem statement first. What problem we are going to solve? Let's have comments. And the problem we are going to solve is, let's define given a list of numbers, for example, i.e., let's say 1, 2, 4, minus 5, 8, 7, 9, 3, 2, like this. Make another list. Make another list that contains all the items in sorted order from minimum to maximum, i.e., your result will be another list like, in this particular case, we will be having minus 5, which is smallest, then we will be having 1, then we'll be having 2, then we'll be having 2, then we'll be having 2, then we'll be having 3. So all the items, but in minimum to maximum sorted order. Then we'll be having, I guess, 4, then we'll be having 7, and then we'll be having 9. So that should be your output in another list. So assume this list is available to you, or any list is available to you. Assume this list is available to you. So how to solve that problem? Let's start. Okay, let's assume that the list is available. Let's say this is the list we are going to sort. Let's say this is available. Okay. Okay. So what should be the logic? What should be the logic? How can we solve that problem? This is an easy looking problem, but it is not so easy. Let us first write let us just simplify this problem to just finding out a minimum from the list. Let's say we are given a list and we just want to find out minimum number, one minimum from the list. So how can we move that? So let's say m is some number. So m is the very first value of the list. M is our variable, let's say. That's the first value. And what we do is for I in L, as long as I is in L, if I is smaller than m, then if I is smaller than m, then m should contain I, otherwise do nothing. That's it. So at the end, print this m. print this m at the end. So print the minimum number, let's say m. Great. So so that's the basically so yeah, that's the that's how we will find out just the minimum value. So let's run this code, and the minimum is -5 available to us. What if we want to store the minimum value as well as the position of that value? For example, we not only want to just find out what is the minimum number, we also want to find out at what index. For example, here 0, 1, 2, and 3. At the third index, we found the minimum. What if we are interested in the index as well? So let's say for the very beginning, the index is 0. And then what we do is we moved on, and we say, okay, we maintain a counter. Let's say a counter is c equals 0, for example, right now, and c just plus equals to 1. That's a counter. And then this idx is just that c, whatever that c is. So whatever that index is, when we find this c, that index is also there. So let's print the index as well as the minimum value. So okay, so at the position 3, at the index 3, we found the minimum value. Okay, now we have written a kind of a code block that helps us finding out the minimum value. How can we actually so the basic logic is you find the minimum value and swap that value with the very first value. Okay, great. And then move the loop. Next time, find out the minimum value from the remaining list and swap that minimum value with the second value. Next time, you find the minimum value as long as the position and swap that with the third value, and so on. So do that stuff and just rearrange the same list using this. But how can, so that's the logic. Find out the minimum value, swap it with the first value, and then start from 2 till end. Start from the remaining values, find the minimum, swap it with the first value of the remaining list. Then reduce the list step by step, and you will be having a sorted order. But how to start with? How to find out like this? How to do that? So any idea? I mean, we are going to, so for example, in this particular case, if I want to swap the list, what I will do is I will say, okay, swap with 0 at the 0. So I will contain a temporary variable. Temporary variable will contain the value of 0, list 0. So what I will do is at list 0, write the minimum value, and the minimum value, so at 0 you write the minimum value, but at this particular index from where we found the minimum value, just place the value at the very beginning. So after that operation, the minimum will be at the first position or the 0th index, and that value will be, so minimum value will be swapped with the very first value. So let's run this code and see what a list looks like after that code. So you see, for example, the minimum value is swapped by the first value, whatever the first value was. But we want to do that progressively for the rest of the list. We want to find out the minimum and swap with the first one for the rest of the list and keep on moving. How can we do that? So yeah, so let me define for, so let me first indent that a bit. Let's say control right braces, that will indent all my code. So for j in range length of the list, whatever the length of the list, let's say for j is that. So what I do is m is the jth value, the index right now is j, and the c is also The counter C is also starts from J. Okay, great. Now we want I to start with now we want this I to start from J and move onwards. Yeah. So let's say I in range, start from J and go till length of L one by one. Take the step of 1. Okay, great. So what next? Now the value will be L of I rather than simply L of I rather than simply I. In that case, you do this. Okay, and the index is just C. Okay, great. Keep on introducing this index again and again. After this loop, what you do is you pick the jth value, you swap the jth value with the minimum, and you do that, and that's it. You keep on moving, and after the outer loop finishes, if you print your list, you will be having the list sorted order. At least we hope so. So maybe there is a bug in the code, maybe there is a problem in the code, but we hope this will work. What we are doing progressively, by the way, this is a nested loop. This is a loop inside the loop, and that's and then we have an if condition inside the nested loop, loop inside the loop. Great. Let's see how it works. If there is no, oh, there is an error, length of range. Oh, we haven't write a colon there. Don't forget this colon. That's a problem. Oh, we have a sorted order. Oh my God, we have a result with us. You see the applications of this. Oh, 1 3 is missing. Where is 3? We have 2 3s. Oh, the output we have written here is wrong. There's no 2 3s. There's only 1 3. So you have sorted a list. If you remember, we have written a similar kind of code in the problem solving session very earlier, where we solved this problem using selection sort. But there we just wrote a pseudocode, and here we have a code much simpler than actually the Python code. If the problem was just sorting, there are built-in functions to do that, but I'm just telling you how these loops and if conditions and all that stuff can be used to communicate with each other, to match with each other, to actually perform a problem-solving task when given a problem. Although we will see later on in Python, most of the problem-solving tasks, I mean many more of them, there are built-in functions for those, there are available functions for those. You need not to write all that stuff, but to master any programming language, you have to go through these constructs, so that for a new problem or for a very large complicated kind of problem, eventually you may need these kind of structures with you. So mastering these structures is really essential for problem solving and programming in general. So okay, that's about the loops and if conditions and control flow, all of that. In the next video, I will start talking about functions. So you have seen this len, that a function. You have seen this range, that's a function. Iterator, although you have seen round function, you have seen div mode, you have seen print function. What if we want to write our own function? How can we do that? From the next video, I'm going to show you how can we write our own function. Wow, isn't that great? That's great. So hope to see you in the next video. In this video, I will talk about functions, a very powerful construct in almost every programming language. Python also supports functions. What a function is, let me describe the need of the function by a scenario. Let me give you a scenario. The scenario is, let's say you are writing a very lengthy program. The program requires to print particular messages whenever needed. For example, you need to print this particular message, the task was successful. Let's say you need to print this, and then you have to print moving to the next task, maybe to inform somebody, maybe to inform your client, and then you have to ask, okay, send me the next task because I'm done with the previous task. Let's say you want to print this, or maybe you want to print more or do some more stuff, and let's say you want to do this again and again whenever needed. Somewhere whenever you complete a particular task or something, you want to print all these messages. And then somewhere else, whenever a particular event occurs, you need to print all these messages again. Now, one way to do that is to write just these print statements whenever needed in the program. One way is if you want to perform a task and the task has a lot of coding, maybe very small amount of coding, or maybe a very large amount or magnitude of the coding. In this case, we have just 3 statements, but maybe we have a task that we want to perform again and again, and it is really a very lengthy task in terms of the coding. So one way to do that is to just write all the coding in coding somewhere and define a function. And that function means the function contains all the tasks that you need to perform. Whenever you need to perform that particular task, just in your coding, just call this one statement, and the whole task that is written under this, maintaining this as a heading, that will execute automatically. That task that is under this heading may be very lengthy, may be short, may be complicated, may be simple one, or anything. But the need is we want to perform this task whenever we need, and we do not try to code this again and again. We do not want to write the same lines of codes again and again and again and again in our program. Just write this particular lines of code once, define a function, just like a task. Whenever you need to perform that task, just call the heading or the name of the function, and the whole task under that function will execute. Functions in almost all programming languages, they do that. Even in mathematics, they do that. In Python, the syntax of defining function is if you want to define a function, you have to first start with DEF, meaning definition or defining. Then you need to write the name of that function. The name of that function, name of function and name of variable has resemblance. the name of function should be descriptive. It should portray what the function actually is doing. So it is good to suggest the names of the functions that are very descriptive to make the code readable and manageable. So here I have written the function name as print success. You can write any name. Then you start parenthesis, then you end parenthesis, and then you write a colon, like you have written the colon for if conditions or for loops or any other constructs. And then you do indent, like the body of the for loop, like the body of the if condition. This is the body of the function. Body of the function should all be aligned. Then you write all the task, all the coding that you need to be performed whenever this function is invoked or called. This body can contain if conditions, for loops inside. This can have a whole lot of coding inside it. And whenever you will call this function, whenever you will type this command, wherever in your coding, the whole task under this will be executed automatically again and again whenever you like. So let's take a look of defining our first function in Jupyter Notebook. Let's just yes. So yeah, so that's our notebook. We were populating that notebook. So by the way, if you want to know where this notebook is located, if I want to for example invoke that notebook again, when you will run your Jupyter Notebook from the Anaconda prompt, you'll be having all the files that you are working on, and one file is, for example, this. You just click on that, and your file, one or more files, whatever you want to open up, that will open up in the Jupyter Notebook. Yes, so it is opening up. It's a lengthy file, so it may take a second. Okay, let me just take a better zoom level just to, okay, so we were working on that notebook. Let's define our first function. Let's say def define. Let's say the function name is print success. That's a syntax. Then you press enter. Print I am done. Then print send me another task. let's say, and that's it. Let's say that's the body of the function. The body of the function here contains only 2 statements. Okay, then you run this command just like Shift Enter. You run this so that it is reported in the symbol table. There is a symbol table inside the Python is maintaining all the variables, all the function information inside. So once you run this cell, then this print success function will be registered to Python, so that whenever you want to call this function again, it will be available. Now, if you want to perform this task, let's say you want to perform this task whenever you want. So you just call this function. This is called calling of the function, whatever I'm doing now, print success, and that's it. You press Shift Enter, and all the statements that are under this will be executed. And you do some other stuff. Let's say 3 plus 8, that is 11. Do some other stuff, and afterwards, if you want to do the same process again, then you call this function again, and all the coding inside the function will be executed. It is very, very handy if a particular task, if you want to perform that task repeatedly, it is good to just write one code for that task in a function and then just invoke function whenever you need. It supplies a lot of managing power, a lot of debugging power. If you have an error, for example, inside the function, you just go to the code, you just go to the code of the function itself and fix the error and come back. You need not to go all over the code. If you have not defined the function and you have called these lines of codes everywhere inside your main code, then it will become very difficult to handle. And function actually provides a lot of simplicity of managing and readability and a modular approach in that sense. So that was our first function. We will be talking about more. Talking more about these functions in the next video. So hope to see you in the next video. The function name should be descriptive. That's okay, but it is further important sometimes to have a documentation of the function, sometimes called the doc string. The doc string allows you to write the description of the function, but that description will never be executed. It will be available whenever you need help or you need to know what this function does. Sometimes it happens your function can contain a lot of code. For example, you have a particular function, let's say fun, let's say it contains def fun, and it does a lot of complicated stuff inside, and it is sometimes required to know what this function actually is doing. So this document string is one way of describing what the function is doing. You might be thinking that if you're writing this document string inside where the coding of the function should be written, we should open up the coding file and see what the function is doing, or should we actually open up this function implementation where the function code is written and then we have to read what the function is doing? Actually, Python gives you another power. If you have written the document string inside, that should be a top statement before the first coding statement. Whatever description you want as a document string, it will be available without actually opening up, without actually seeing what inside the function, without actually opening up the file that contains the implementation of this function. Let's see in Jupyter Notebook in more concretely whatever I'm saying right now. So for example, let's define a function def print success 2. Let's say the function name, this function is print success 2. The function name is print success 2, although it's not a very descriptive name, but the spellings are also not correct, but that's fine. Print success 2. Here I just define a document string. The document string may contain maybe just in one line, or it may be a multi-line. It is like a multi-line comment, or maybe a single line comment if you want. But it starts with 3 quotes and ends with 3 quotes. Let's say I write here, this function is doing nothing except printing a message. Printing a message, let's say full stop. And then I further define, let's say I define more in saying that that message is hello, let's say, or any description you want for this function. Now this is the document string and it will be available whenever you need. Now here the coding starts. Let's say you write a coding here and you get hello, let's say, and you run this code. Now let's say we are not seeing this function. We are not available with this function. We are not available with the code of this function, and we want to know what this function actually does. First of all, we can just write, if we write PRI and just press tab, the tab will allow us to access all the functions that are available with prefix PRI. So let's say we go to print success, here print success, S should be capital, print success, let's say, so print success 2, let's say, and we write a question mark in front of it and then just press shift enter. It will pull the document string, whatever we have written, and we will get to know what actually this is doing. So this document string actually does a lot of job. Further, if we, this is kind of whenever we need to know what a function is doing, the document string is one way to just go and check what is happening. Right now, this function implementation is in front of us, but in several times the function implementation will not be in front of us. Several times we will be accessing functions that other people have written in their libraries. And we need to know what those functions are doing. So document string is one very, very healthy way of describing our function. And I will recommend to make your habit writing document strings every time you write a function. I was telling you that if you write a double question mark, then it will not only pull the document string for you, it will pull the whole implementation as well. So now if you see, this is the document string and that's the implementation. So whole implementation will be available if you want. And this is true for the functions that are third-party functions, or some other person have written that function and so on. For example, a function length, we have called that function several times. So let's see. So the document string is return the number of items in a container. That length function is not written by us. Somebody have written that function. That's a built-in function, by the way. And this document string tells us, okay, what this function is doing. We don't have the implementation of that function. Obviously, somebody have written that function. And if we write the double, then we should get an implementation as long as the implementation is not in C++. I haven't told you that a lot of implementation of Python itself has been done in C and some other languages, C mostly. So several built-in functions, because of their speed, they are implemented in C. And if you want to get their implementation, get their code, the code will not be available for most of the functions. So whenever you write a double question mark and the answer is the same as a single question mark, that's an indication that this particular function is not written in plain Python. It is written in some other language and is used in Python. That's another versatility or flexibility of Python. You can engage multiple languages inside. Okay, one more thing. I can write help command, and I can get this print success success 2, and the help of print success 2 by just typing this help command. So this help will tell us, you see, the help is telling us the document string. This help on this function. And this is the function we have written. This is the function we have written. This function is doing nothing except whatever description we are giving there. If at some time, if we are supplying this function to somebody or making a package of a lot of functions that we are writing, these document strings will help to get to know how to use these functions. By just knowing the function name, this document string actually tells us what the function is doing. Wow, great. Oh, by the way, we haven't called this function yet. We are just playing with the document string. Let's call the function print. Now we know what the function is doing. Let's call this function. And whatever written inside the function will be called. See, this is only called, this is just acting as a comment, and it is basically a comment. Yeah? Okay, great. Stay with us. There is much more about function that we are going to tell you. Hope to see you in the next video. Okay, in the last video we saw document string. You might be thinking, what is power of this function if it is doing some static task? Well, in this video I'm going to tell you that the function the coding or the behavior of the function can be dynamic based on the arguments, based on some properties that you will be defining at the call time. For example, the function has, in almost all programming languages, the most interesting functions are the functions that receives an argument, and an argument is just considered an argument just as a variable, and performs its task according to that argument. Just take a simple example. Let's say rather than having a function print success, we have a function print message, and it prints whatever message it receives. And at the call time, for example, we call this function like so print message, and let's say we call this as let's say success. Let's say now success will be printed. Next time we call the function and we give another argument, maybe in a string, let's say 74 errors, let's say, that will be printed, or anything. I mean, anything that you supply will be printed. Wow, isn't that great? I mean, one function, and you might be thinking, the plain print function does that. What's the power of this? Well, I'm just telling you, the function does not only contain one line. I mean, it can be a whole task depending upon this input argument, and the whole task will perform dynamically based on what input argument you are supplying there. You are noticing one thing that I just forgot. What is that thing? I defined this function. I guess everything is fine. I've just missed something. Oh, document string. I should have written document string. Although document string is not essential, if you do not write document string, it's perfectly okay. The function will run, but it's a good practice. It's a good habit to always write a document string. Okay, let's see the power of input arguments by, again, going to our good friend Jupyter Notebook. Okay, so let's see. Let's say we define a function, define print message, let's say, and it receives an argument message. And this argument is just a variable. It's just a variable. And let's say we say, okay, print message. Or further, let's say we say if is instance message string. If this is string, then simply print it. If this is not a string, then just say okay, print your input argument is not a string, and then you say okay, here is what you have supplied, and then you say okay, whatever you have supplied, just see okay message, and that's it. That's a function. We might have written a document string for it. The function prints the message supplied by the user or prints that message is not in the form of string. Wow. Don't worry, we have to see the strings in detail. We will see this print function in detail as well, because this print has a lot to do with strings. So just for now, I mean, that's our function, print message. Let's say if the message is of string type, this string does not, this should be simply str, this should not be that, is instance take like this. Your input argument is not a string. Here is what you have supplied. Here is what you have. So here we can say here is the type of what you have supplied, and then we can just print the type and type of MSG. So the goal here is to just write a function that prints a message if that message is in plain string form. If it is not a string, then it prints that, okay, the whatever you have sent is not a string, it is not a proper message in string form. Let's say this print message function receives a string, let's say. That's our logic or something. So let's run this. First of all, let's see what it does. Help print message. So the function prints the message supplied by the user. We can access the same help by question mark if we want, and it gives us the document string. If, however, we want the implementation as well, then we write a double quote, and the implementation is also available. Wow, great. Python is really great. Okay, let's call this function. Yeah, let's call this function. Print message and whatever you want to print. Let's say this is the message. This is the message. Let's say you want to print this, and this is the message that's printed. Okay, now let's say you call this function again sometime and you supply 23, and it will say your input argument is not a string. Here is the type of what you have supplied. It's an integer type. Great. You can call this function in the following way. Let's say you define a variable y, and the variable y contains hello. Hello there. Let's say that's your and then you call the this function on y, and it will print hello there, because y is also a string. Great. So that's how you can pass different arguments and instruct the function how should it behave without actually writing the whole logic of the task again and again. You have written all the logic once. Actually, the logic starts from here. That's what the task is to. That's what the task you want to perform, and you need not write this again and again whenever you need this kind of stuff. You just call that function, supply it arguments, and it will behave accordingly you want. Great. So you might be thinking that a function only receives one argument. Maybe we want to supply more than one arguments, maybe 2 arguments, maybe 3, maybe 4, maybe 5, and maybe we want to supply several arguments, and we want to do some task based on the values of those arguments or those variables. So in the next video, I'm going to show you multiple arguments. Okay, hope to see you in the next video. So in the previous video, we saw we can define a function and we can supply input argument to it. And in this video, we are going to see that we can actually send more than one arguments to the function. These arguments are just variables. These are just variables. Whatever value we will supply to these dynamically, because Python is dynamically typed, dynamically their type will be defined. And for example, here we have supplied just 2 variables and we just printed them. but based on supplying more than one input arguments, and based on what logic we are going to perform, we can do anything. Yes, Python allows us to supply multiple input arguments to a function, and we can just perform all the tasks according to whatever logic we are going to do with that. So let's go to our friend Jupyter Notebook and see an example of a function with multiple input arguments. Let's say the function we define a function. Let's say my power. Let's say my power. Let's say you remember there is a POW function in Python. That's a built-in function. I'm going to write my own function. Let's say it contains A and B. Well, document string. This function computes power just like built-in power function. Great, that's the document string. Okay, now what we want to do is we want to print. Okay, let's create another variable C, that is A power B. Okay, then we print this C and we are done. Let's say that's our goal. So we register that function by just calling by just pressing the shift enter in Jupyter Notebook, and now we check what this function does. Well, this function computes power just like built-in power function. Okay, just to remind you again and again the importance of document string, I'm writing this again and again. Let's run this function. My power, let's say 3 raised to the power 4. I want this. So the result is 81. Oh my god. So whenever, by the way, if you don't have POW function with you, although you have, you can create your function, and whenever you want to use, you can use your function. Not a big deal. Yeah. By the way, what if you you can define a function with more than 2 arguments. Define, let's say, display types. Let's say that's your function, display types, and all you know is or check arguments. Let's say check args. Let's say that's your function, and A, B, C, D, let's say E, these are the input arguments. And let's say at some task you want to know whether all the 5 variables that you are working in somewhere, whether all of them are numeric values or not. If they're not numeric values, you're not moving on and you are doing something because you were let's say you're taking input from somewhere, reading from a file or whatever, and you need to check before moving on whether A, B, C, D, and E, whether they are ints or floats. Otherwise, if any of them is not int or float, then you're not processing, then you're not moving on, and you're going to check the input arguments again and so on. These kind of functions are there because whenever you call certain whenever you want to do processing on data, sometimes it is required to check the type of the data, whether the data is supplied in a way that you were expecting and so on. So let's have this function check args. I'm not writing document string here. I guess I've told you enough to write document string again and again. So let's say if is instance A, if is instance int float, if that is true, and is in, let's just have 3 variables just to focus on. If is instance A, then B, and is instance C if all of them are integers or floats, then do something. Then let's say print a plus b plus c maybe, or a plus b plus c raised to the power 2. Just print their square, let's say. Else or if they are all integers or floats, then do some interesting task here, some task. Otherwise you can say, okay, print an error, the input arguments are not of the expected types. Fine, you have this function. Let's call this function. The function was check args, so let's check args. Check args, let's say 3, 4, 5. So now you have all of them are great. Let's say you have check args, and you call this check args on, let's say 3, 4, but this 5 is a string, let's say G. Now you'll be having an error. The input arguments are not of the expected types. One of them or more of them or whatever. Yeah. One more thing. This function is expecting 3 arguments. If you call this function by less than 3 or more than 3 arguments, you'll be getting an error. For example, 3, 4. Although this function is accepting 3 arguments, you're calling it with just 2, you're getting an error because you have not specified all the arguments that the function is requiring. Although the arguments that you have supplied, they are of the type that it is expecting, but you have not supplied the number of arguments that the function is expecting. Similarly, if you call this function by more than 3 arguments, although it requires 3 arguments, you again will get an error because it is expecting 3 arguments and you have not supplied 3 arguments. Later on later on we will see how to write a function that accepts variable number of arguments. We will see that, but right now in this particular way, if you write the function if you define the function in this particular way, you have to define the arguments, the number of whatever the number of arguments it is expecting, you have to supply exactly as many, otherwise you are getting an error. Okay, so that's about the multiple arguments. Okay, what next? Well, next time in the next video we will see that what is the importance of order of these input arguments. What will happen if I just swap message 2 and message 1? Will that change the behavior, or is there any order? The first variable, the second variable, third variable, is there any ordering inside the input arguments? Yeah, there is. So let's see in the next video. In the last video we saw how can we how can we define a function with more than 1 input arguments. It is important to know that the order of the input argument is really important. So whatever argument at the call time, for example, if you call this particular function, the name of the function is f. That's not a great name. You should have a name that is descriptive, but I recommend to write good names. Let's say this is f, that's a function, and the very first variable is c2, the second variable is c1, the third variable is c3. Now you, let's say, call this function like this, let's say 2, 4, and 9. What will happen is this 2 will be copied in c2, this 4 will be copied in this c1, and this 9 will be copied in this C3. Now C2 has a value 2, C1 has a value 4, and C3 has a value 9. If you change the symbols or the variables order here, whatever order you have written there, the first value that is passed at the call time will be passed to the first variable, whatever the name of the first variable is. The second value at the call time is copied in the second symbol, whatever the name of the symbol is. So this ordering is really, really important. One way to one workaround for this is at the call time, you actually define the variable names and their values. For example, you call f and you say, okay, C1 has this particular value. But this way you need to know that there is the symbol name in definition is exactly C1. So C1 has this value, C2 has this value, C3 has this value. Once you, at the call time, if you have defined your variable names along with their values, then you are order free. Now you change whatever, if for example you call this way, C2 is B, C1 is A. Now no matter in what order you have called these, this C1 is going to be copied in C1, this C2 is going to be copied in C2, and this C3 is going to be copied in C3. For the functions that has many more arguments, it is good to call the function in this particular way if there is a chance that calling a function in a different order may become confusing and stuff like so. This actually gives you more grip on this ordering issue. If you're happy with, if you're very smart and you say, okay, I will always supply in a particular order, I will always read the document string first and then I will call that function, that's okay. Otherwise, this is also a feature that is available. At the call time, you assign the values of the functions that are there at the definition time. And now, no matter in what order you are calling that function, C1 occurs at third position, C2 occurs at first position, the relative values will be copied according to their names. So, and that's a good feature. That's a very good feature. Let's see, for example, a running example of this in Python, in Jupyter Notebook. Okay, define, let's say function f. Let's say it receives A, B, and C. Let's say 3 values. And let's say it prints A is, let's say it's print A is A, and you say okay, B is B, and then it prints okay, C is whatever the value of C is, that's a C. Okay, now let's call this function f with, let's say 2, 3, and game. So we will say okay, A is 2, B is 3, C is game. Fine, great. Now this 2 will be copied in A no matter what. If we change this calling order, for example, if we change this order, we just move to this particular order. We just say okay, this is 3, this is game, this is 2. If we call like so, now 3 will be copied in A, game will be copied in B, and 2 will be copied in C. And that, if that is the behavior you want, then you are good to go. Otherwise, it is handy to call the function in the following way to just fix, okay, A is 2, fine. B is 3, and C is, let's say, game. If you want these numbers. Now, if you call the function like so, that will happen. Now, if you change the order, no matter what order of at the calling time you come up with, it will stay the same. For example, you go and say, okay, C is at the first position and A is at the second position, let's say 2, and B is at the third position 3. The output will stay the same, and that's a beautiful thing. So that's one way of handling with the order. If you